masuk terus lah sebab dah 9.30 dah ni. Dah nak 9.30 dah. Terus race D.
Cikgu Amira dah masuk belum?
Dah.
Dah.
Prof, can you send...
Sayangan, saya call dia tak angkat.
Allahu Akbar.
Mana tahu Miro call dia angkat.
Okay, jap.
Ina pun try call tadi tak dapat lah. Sebab Ina call through Telegram mungkin.
Try Cikgu Miro pula. Dia dengan Cikgu Miro, dia sayang Cikgu Miro.
Prof Husin boleh share dah. Saya rasa link dengan speakers kita supaya diorang boleh masuk terus. Dah nak 9.30 dah ni. Ina share dekat Mr. Azrai jap.
Dengar.
Siapa tengah menjerit kat background tu?
Window. Okay. Dia dah ada lampu putih. Nampak ke ni? Sekejap, let me see. Okay. Dah ada video ke?
Okay, hello. Dengar tak? Prof Husin ada? Prof Husin? Prof Husin? Prof Husin, I cannot hear you. You ada tak bersama kita?
Can someone share the link to Azrai?
Yeah, I have already sent the link to him. Speakers kita dah, yang lain dah dapat dah ke link?
I already sent to Mr. Nasri.
Alright.
Cik Ramlan, they can straight away using the UiTM post.
Alright. So we will first have a little short brief. Oh, kenapa? Oh, it's okay. Anyway, so once the speakers dah masuk, we'll first have a short briefing on how the event will go, a little short rehearsal, test all the technicalities, test the slides, and then by 9:45, I rasa dah okay if we ajak the VIPs to join us bersama kita hari ini so that they can have a rough understanding of the event. Is that okay with everyone?
FB Live ready
FB Live ready?
FB Live ready, maybe check dia punya ni audio system, okay?
Aiman? Yesterday Aiman slept at 4 o'clock trying to figure out the audio. InsyaAllah hari ni okay.
Okay. And then I will control the participant coming. Then for the pin, I think Aiman will control the pin for the speaker and also the poster to be displayed during the event.
Who will be control of the pinning? Prof Hussein, is it? Or Aiman? I'm not sure.
Because the FB is controlled by Aiman. So and then all the screen, Aiman will control the pin. I will control the participant.
Alright. Do make sure to mute anyone's mic that will disturb throughout the event. Okay, so sekarang ni kita tunggu the speakers lah to join us so far.
I dah boleh email link Facebook Live
Boleh. Aiman boleh kan? Nanti pukul adalah nanti kita akan test sekali semualah video kita, slides kita macam mana before cikgu-cikgu semua lain dan participants masuk. Assalamualaikum Prof Zaki.
Waalaikumsalam.
Selamat pagi. Selamat pagi. Oi.
Pengetua dah nak link ni. Sekejap saya emailkan, saya sendkan link dekat ni. VIP masuk. Okay. VIP kita ada VIP.
Test. Bismillahirrahmanirrahim. Assalamualaikum everyone. And a very good morning. So we'll be starting soon.
Okay, Assalamualaikum Puan Roslina. Puan pengetua kita baru masuk.
Waalaikumsalam warahmatullahi wabarakatuh.
Assalamualaikum Puan Rusila. Can you wait a brief moment for the speakers to join? I'm so sorry for the delay,
Okay.
and I'm so happy to have you here join us today.
Okay, thank you, my dear.
Saya tengah akan jemput ni Pro Nazib kejap lagi.
Okay.
talking about the introduction to vehicle dynamics by estimated time 10:30 a.m. Followed by a Q&A session and the next speaker slot at 11:10 a.m. estimated time with our second speaker of the day, Mr. Azrai, and he will be talking about his experience in F1 in schools as a former SMK Section 9 student, F1 in schools SMK Section 9 student, I'm sorry, and proceed by having our last slot of the day with Mr. Ahmad Nasri Shafie at 10:30 a.m. estimated time, that will be sharing his first-hand experience as a former F1 Trackside Engineer, and then the last Q&A slot of the day, and we'll wrap up the event around 12:15, if that's okay with everyone. Is everyone clear with the tentative for today? Is there any questions before we start? No?
Yeah, all clear, Rina.
All clear. Okay. If everything is clear, I think so we should do just a brief rundown of the whole flow so that there will be so we can avoid as much technicality problems as possible. For the brief flow, I would like to have all our speakers present their slides in order and just briefly go through them so that we know that you guys can present your slides, and maybe we can show a little bit, test the audio for the videos that will be presented shortly. And we will also brief the VIPs on their cue to have the opening remarks. Is that okay with everyone? All right, so I'll start. Christina?
Alright. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan selamat pagi kepada semua para hadirin sekalian, terutamanya yang dihormati Puan Roslina binti Ahmad, Pengetua SMK Section 9 Shah Alam, Mr. Ahmad Gaus, YDPP IBG SMK Section 9, dan Profesor Dr. Nazib Suratman, Deputy Vice Chancellor of UiTM. I'm Wan Christina.
I'm Irina Wanzul, and we will be your moderators for the day. Many of you here may or may not know us. We're from SMK Section 9, Keris Racing's F1 in Schools team that, despite a roller coaster of a year, won the 2020 National Champions title.
But before we can invite you to join our next journey to the World Finals, we have prepared a short summary of the previous chapter to our story, our road to nationals, for you to follow along.
Okay, Iman, could you please share your video presentation and just check the audio? You don't need to play the whole video. All right, thank you, Iman. Okay, that's it. I hope you guys found that intriguing, but our story doesn't end there, as the chapter of our journey to the World Finals is just beginning.
And we would like to thank everyone here today for joining this journey with us by being a part of our webinar series Inside the Minds premiere.
The motive behind this webinar series is to share experiences and knowledge on various aspects that correspond with this prestigious competition to a wider audience. So welcome to the first episode of Inside the Minds. In this episode, we'll be talking about engineering insights with some very special guests.
But before that, saya ingin menjemput Puan Roslina Ahmad, Pengetua SMK Section 9, diikuti dengan Encik Ahmad Gaus, YDP PIBG SMK Section 9, dan Profesor Dr. Nazib Suratman, Deputy Vice Chancellor UiTM, untuk memberi sepatah dua kata pembukaan. Dengan segala hormatnya, mempersilakan.
Alright, so this will be the slot for all of our VIPs to give a little bit of kata-kata pembuka for the event. I hope you guys don't mind that the slots will be consistent. So maksudnya after Puan Roslina
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan selamat pagi kepada para hadirin sekalian. Terutamanya yang dihormati Puan Roslina Ahmad, Pengetua SMT Seksyen 9 Shah Alam, Encik Mohammad Daud, YDPP IDG SMT Seksyen 9 dan Profesor Dr. Natik Razman, Deputy Vice Chancellor of UiTM. I'm Wan Christina. Arina, you're mute, please.
Oh, I'm so sorry. And I'm Irina Wanzo, and we will be your moderators for the day. Many of you here may or may not know us. We are from Team Keris Racing, an F1 and Schools team from SMK Section 9 that, despite a roller coaster of a year, won the 2020 National Champions title last year.
But before we can invite you to join our next journey to the World Final, we have prepared a short summary of the previous chapter to our story, our national, for you to follow along. We have a team that is representing SMK Section 9. Now this team is actually called Keris Racing. Keris Racing.
Hi, my name is Irina, and this is, and we are from
Keris, I said make one up. Keris.
suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire. With crimson secrets and forbidden bliss, can't stay still, don't stop that thrill. My bones crave your skin, temptation within, mistakes ignite the silence. Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Wow. Okay, I hope you guys found that intriguing, but our story doesn't end there.
Now
As
that,
the chapter of our journey to the World Finals is just beginning.
now that we're looking back, I think I kind of miss National. So, without further ado, we would like to thank everyone here today for joining this journey with us by being a part of our webinar series Inside the Minds Premium.
The motive behind this webinar series is to share experiences and knowledge on various aspects that correspond with this prestigious competition to a wider audience. So welcome to the first episode of Inside the Minds. In this episode, we'll be talking more about engineering is science with some very, very special guests.
But before that, saya ingin menjemput Puan Rosina Ahmad, Pengetua SMK Seksyen 9, diikuti dengan Encik Muhammad Gaus, YDP PIBG SMK Seksyen 9, dan Profesor Dr. Nazif Suratman, Deputy Vice Chancellor UiTM, untuk memberi sepatah dua kata pembukaan. Dengan segala hormatnya, mempersilakan.
Terima kasih kepada Wan Kristina dan Erina. Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. Saya ucapkan kepada yang berbahagia Prof. Dr. Nazif Suratman, Timbalan Naib Chancellor UiTM, yang berusaha Encik Muhammad Gaus bin Ahmad, YDP PIBG, Prof. Dr. Muhammad Hussein, Naib YDP PIBG, barisan-barisan penceramah kita hari ini, Encik Ramlan, saya tak ingat nama penuh, Encik Ramlan, Encik Ahmad Nasri dan Encik Azrai, barisan mentor-mentor kumpulan Keris Racing F1 in School, anak-anak Keris Racing, anak-anak Rimau Racing, barisan peserta-peserta webinar. Selamat datang. Terima kasih saya ucapkan kerana sudi bersama-sama kami dalam webinar episod 1 yang dianjurkan oleh kumpulan tim Keris Racing. Ya. Jadi pertama sekali syukur alhamdulillah kerana kita diberi kesempatan untuk bersama-sama menyertai webinar yang jelung-jelung kali diadakan. Ya. Jadi walaupun dalam norma yang baru, kita secara atas talian kita dapat juga bertemu dan anak-anak Niners, anak-anak Keris Racing dapat menganjurkan program ini tahniah dan syabas diucapkan kepada tim Keris Racing atas usaha menganjurkan webinar ini mudah-mudahan melalui webinar ini kumpulan anak-anak Niners yang lain kepada pihak-pihak luar di sana, mereka akan lebih mengenali apa itu F1 in schools, perkara-perkara yang terlibat, apa yang perlu dilaksanakan dalam menguruskan pertandingan F1 in school. Terima kasih juga saya ucapkan sekali lagi kepada barisan penceramah kerana sudi bersama-sama dengan anak-anak Keris Racing, Encik Azrai, Encik Ramlan, Encik Ahmad Nasri. Sudah pasti kepakaran mereka dalam bidang F1 in school dan juga bidang kejuruteraan automotive akan membantu memberi penjelasan yang lebih jelas, memberi penerangan yang lebih jelas kepada pihak luar dan juga anak-anak Niners dan membantu mereka menguruskan kumpulan F1 in school ini. Selain daripada itu, saya amat berbanggalah dengan pencapaian anak-anak Niners, terutama kumpulan Keris Racing. Tahniah kerana telah menjuarai F1 in Schools National Finals. Dan begitu juga dengan anak-anak Keris Racing yang juga akan menyertai pertandingan mewakili Malaysia. Saya difahamkan tahun ini dua kumpulan daripada SMK Seksyen 9 iaitu kumpulan Keris Racing dan juga kumpulan Rimau Racing yang akan menyertai pertandingan World Finals F1 in School. Walaupun secara virtual tetapi kerja-kerja yang perlu mereka laksanakan memerlukan perhatian, memerlukan komitmen, memerlukan masa yang sangat banyak dalam menyediakan model-model kereta untuk menyertai pertandingan tersebut. Alhamdulillah melalui penglibatan mereka dalam pertandingan ini, mereka telah menjadi anak-anak yang pada saya sangat cemerlang. Mereka define themselves, menjadi lebih confident, terutama dalam menguruskan, contohnya menguruskan webinar seperti ini. Siapa sangka anak-anak Niners selepas diberi pendedahan sebegini, mereka berjaya untuk mengetengahkan diri mereka menjadi lebih confident. Harap-harap semoga mereka akan terus berjaya. Kita boleh nampak juga contohnya salah seorang penceramah kita juga, Cik Azrai, merupakan bekas pelajar yang menyertai kumpulan F1 ini. Mudah-mudahan melalui webinar ini ia dapat lagi memberi pencerahan kepada seluruh warga Niners dan juga pihak-pihak lain tentang kepentingan anak-anak murid menyertai pertandingan-pertandingan seperti ini sebab kesan dia, impak dia sangat-sangat besar. Jadi sebelum saya mengakhiri ucapan saya tak lupa juga nak ingin mengucapkan jutaan terima kasih kepada barisan penyumbang-penyumbang, penyumbang dari segi sumbangan dari segi kepakaran, iaitu daripada Prof Husin and team, Prof Husin, Dr. Azli and kumpulan-kumpulan tenaga mentornya daripada Mechanical Engineering Department UiTM, daripada 3D Gens dan juga daripada Sirim. Ini mereka telah menyumbangkan kepakaran kepada tim Keris Racing dan juga Rimau Racing. Begitu juga dengan penyumbang-penyumbang dari aspek kewangan, Supreme Fintech, PIBG, SMK Seksyen 9 dan juga para ibu bapa yang telah banyak memberi sokongan dan juga sumbangan kewangan. Terima kasih yang tak terhingga daripada kami kepada semua penyumbang-penyumbang tersebut. Jadi saya tak nak lagi bercakap panjang lebar. Semoga harapan saya semoga tim Keris Racing dan juga Rimau Racing insya-Allah akan beroleh kejayaan di dalam pertandingan F1 In School World Finals kelak. Semoga dapat mengharumkan nama negara, seterusnya nama sekolah lah secara khususnya, insyaAllah. Semoga melalui program ini dapat lagi meningkatkan minat murid-murid dalam bidang sains dan teknologi, engineering dan juga matematik ataupun ringkasnya STEM, meningkatkan kemahiran murid dari aspek inovasi dan juga kreativiti. On that note, saya sekali lagi ucapkan jutaan terima kasih kerana menjemput saya untuk bersama-sama dalam webinar ini. Itu saja daripada saya. Sekian. Wabillahi taufiq wa hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih Puan Rosina binti Ahmad, Pengetua SMK Seksyen 9, Encik Muhammad Gaul untuk memberi sepatah tugas.
Bismillahirrahmanirrahim. Yang saya hormati Puan Roslina binti Ahmad selaku Pengetua SMK Seksyen 9. Yang saya hormati Profesor Dr. Mohammad Nazri Mohd Shafie, Timbalan Naib Chancellor UiTM. Rakan saya Prof Hussein, guru-guru, anak-anak dan tuan-tuan dan puan-puan yang kasih sekalian. Lebih dahulu saya selaku YDP PABG ingin ucapkan tahniah dan syabas kepada Keris Racing Team telah menjadi juara kebangsaan dan akan mewakili negara ke peringkat antarabangsa. It's a big achievement dan saya pun telah diberi taklimat oleh Puan Kasnani, guru F1 Racing, Keris Racing dan juga Cikgu Amirul serta dengan Profesor Hussein, dan insyaAllah sebaik mungkin PABG akan memberi sokongan baik dari segi kewangan dan juga bantuan-bantuan yang perlu supaya pasukan ini dapat buat yang terbaik lah, do your best in this international platform. Dengan doa dan kerjasama yang baik, kita berharap this team can become the world champion, insyaAllah. Number dua, I would like to thank also Professor Dr. Mohammad Nazri Mohd dan juga UiTM kerana sentiasa memberi sokongan lah kepada pasukan ini. I can see a lot of UiTM people here, and sebagai alumni, I'm very proud of UiTM, and I hope this continuous support for the team can be maintained, and we can get this every year for next years to come. And webinar ni sangat baik bagi saya. Ia merupakan satu cara untuk memberi pendedahan supaya kita ada continuity. In any work we do, we should have a continuity. Kita nak sekali buat setahun dan apa kata pepatah hangat-hangat tak ayam lah. So we should have continuity. It is a good platform for us to encourage kita young lah, memang semua ni young, tapi we are talking about the new junior, anak-anak yang lain untuk mempunyai minat. And I believe all of you with the existing Keris Racing team mengalami experience yang sama when your seniors about 2-3 years ago participated in this sort of tournament, right? So continue doing this webinar. Kita nak encourage so many other students that can actually participated in this sort of event. And I can see the excitement, the passion from the Keris team, and I can see I'm also an engineer. I can see that you already have that sort of macam charisma to become a good engineer in future. Keep it up. InsyaAllah sebaik mungkin kita akan memberi sokongan ibu bapa, PIBG dan semua warga SMK 9 akan cuba memberi sokongan yang terbaik for you guys to be prepared and participating in this coming international event. InsyaAllah sama-sama kita doa dan supaya webinar ini dapat berjalan dengan lancar. And I was told this a series, a few series, dan we like anak-anak yang lain to be encouraged. Maybe today could be 60, the next one could be more than that, to be encouraged to be able to be involved in this F1 in school. Sebenarnya sebelum ni saya tak tahu sebenarnya F1 school ni. Until I was get into this PIBG, barulah saya tahu this something that is supaya pasukan berjaya. InsyaAllah this webinar will be a good ignition for the rest of the keluarga anak-anak di section 9 ni, Niners, untuk be involved. Thank you sekali lagi. Saya ucapkan kepada organizer kena menjemput saya for this good event. Okay. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you. And now I'll invite Professor Dr. Nazir Sherman, Deputy Vice Chancellor of UiTM.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Yang bahagia Puan Rosina, selaku Pengetua Sekolah Menengah Kebangsaan Seksyen 9, Cik Ahmad Gaus, YDP, PIBG, dan seterusnya barisan guru-guru di sekolah Seksyen 9, Kebangsaan Seksyen 9, dan seterusnya peserta webinar, dan juga tahniah diucapkan kepada Keris Group yang telah mengajukan program webinar ini, terutamanya kepada mentor, kepada penasihat, Profesor Madya Dr. Husin dan rakan-rakan yang sentiasa ingin melihat perkembangan STEM, perkembangan pendidikan kejuruteraan di kalangan murid ini berkembang. Jadi ucapan tahniah sekali lagi kerana dapat sampai ke peringkat ini. Jadi saya boleh juga mewakili UiTM ingin memberi sokongan, dan saya pun berterima kasih kerana telah dijemput pertama kali hadir ke Sekolah Menengah Kebangsaan Seksyen 9 untuk turut sama di program Festival STEM tahun 2019, dan saya juga mengikuti perkembangan semasa kemunculan pasukan ini di TV nasional, di social media. Jadi tahniah, ini satu strategi publicity yang sangat hebat. Dan seterusnya saya mengucapkan terima kasihlah kepada pembentang webinar pada hari ini, Cik Ahmad Nasri Mohd Shafie. It's good to see you again, Cik Ahmad Nasri. We met in 2019 at school during coffee break. And also thank you also to Cik Mohammad Azrai Azmi. So you are actually it's your alma mater. You're coming back to school to serve, to contribute to your ideas. Well done and congratulations. And my colleague, not forgetting my colleague, Cik Ramlan Kasiran from UiTM Faculty of Mechanical Engineering. Thank you for continuously providing support to the school. And kepada Prof. Madya Dr. Husin, tahniah. Dan we will always work together, in order to inculcate the spirits, the culture of innovation, of STEM among the school children. Kita ingin melihat dari segi kesinambungan, aktiviti yang pelajar-pelajar sekolah jalankan di peringkat sekolah dalam membentuk kreativiti dan inovasi. Jadi ianya akan berterusan, insyaAllah, apabila pelajar-pelajar ini melangkah ke Menara Gading, mana pun tak kira, di UiTM pun kita ada 4 fakulti kejuruteraan. InsyaAllah sekarang ni telah menjadi kolej kejuruteraan untuk memperkasakan lagi agenda kejuruteraan. Jadi UiTM sentiasa membuka peluang kepada anak-anak semua untuk meneroka dengan lebih mencabar lagi bidang kejuruteraan ini di bawah guidance Dr. Husin dan rakan-rakan. Jadi sekali lagi ucapan tahniah diucapkan. Selamat mengikuti webinar kepada semua peserta. I can assure you this is going to be a very fruitful, productive session. Dan terima kasih sekali lagi kepada puan pengetua, Tuan YDP, PIBG yang sentiasa memberi sokongan kepada program seperti ini. Sekian, wabillahi taufiq wa hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih atas ucapan yang berbaik.
Thank you so much for the kind words. I think so before we can start this webinar and move on to our first speaker, may I kindly ask everyone to open your cameras so we can take a big group picture with all our VIP guests for today. So everyone, can you open your cameras, especially cikgu-cikgu dan prof-prof yang join kita hari ini. Okay, we're waiting for everyone. Cepat-cepat. Okay, so we have all of our VIPs. So buka camera. Murid-murid can also join. You guys can also join and open your cameras. All of our participants today. We will feature you in our portfolio and verbal presentation if you do so. Wah, agak ramai ya sambutan kita pada hari ini. Thank you so much for joining us. Maybe Cikgu Amira boleh ambil screenshot? Do count to 3 so we all prepared.
Okey, sekejap ya. Okey.
Murid-murid jangan lupa open your cameras.
1, 2, 3. Alright. Okey, sekali lagi. Baik, 1, 2, 3. Alright. Okay.
All right, thank you so much. All right, so I think so before we catapult to the event, I would like to kindly remind everyone to stick till the end of the webinar to receive your promised e-certificate. So do stay till the end for that.
Untuk students, it will be considered as peringkat negeri, and kita pun tak terlepas juga kepada para guru semua. Termasuk para guru di bawah jemputan JPN, saya ingin memaklumkan bahawa pada hujung webinar ini, kami akan memberikan QR code yang akan membantu menaikkan mata SPL KTM anda.
Without further ado, we would like to invite our first speaker of the day, Mr. Ramlan Kasiran, that will be sharing a little bit about the introduction to vehicle dynamics. Okay.
Mr. Ramlan Kasiran. Mr. Ahmad Nasri, upon achieving a master's in science engineering and automotive engineering, has since held various positions in the industry from 1991 till 2007. Currently, a senior lecturer at the Faculty of Mechanical Engineering UiTM since 2008. Not only does Mr. Ramlan teaches numerical methods, statics and dynamics, but he also has established the team Faculty Kejuruteraan Mechanical FKM UiTM, which was involved with Pro 2 Eco Challenge in 2009. Team FKM UiTM 0E, a fuel cell car, and was also involved with the development of Team Azrai Azmi for the Shell Eco Marathon in 2009. Despite being heavily involved with the students of UiTM, he has also devoted his time to several F1 in schools and Land Rover 4x4 in school students such as Infinite 9, Synchro 9, Rimau Racing, Valiante 9, and currently Team Keris Racing's mentor. Arina, you're muted.
Sorry, I'm so sorry. Hi and good morning, Mr. Ramlan. You may take it from here. Remember, para hadirin, a Q&A session will be opened at the end of Mr. Ramlan's talk. So kindly keep your mics closed till then.
Alright, thank you Arina and Christina for the short introduction about myself. Okay, saya tak perlu kenalkan diri saya lagi lah. Nama saya Ramlan Kasiran. I am the lecturer at the Faculty of Mechanical Engineering. Okay, selamat pagi. Assalamualaikum kepada Puan Roslina, pengetua guru-guru SMK Sekolah Seksyen 9, kepada Prof. Mohammad Nazib, profesor-profesor dan juga pensyarah-pensyarah yang ada hari ini, kepada YDP, Cik Muhammad Gaus, pelajar-pelajar dan semua anak-anak yang hadir pada hari ini. InsyaAllah kita akan belajar sesuatu. Hari ini saya punya lecture basically on introduction to vehicle dynamics. Okay, so boleh saya mula saya punya presentation now. Lebih kurang 30 minit and then we have Q&A kalau you all ada soalan. Alright. Okay, this is the title, Introduction to Vehicle Dynamic, and how this basically vehicle dynamic related into what we call the science, technology, engineering, and mathematics. This is basically one initiative by F1 in school to actually encourage students to appreciate science, mathematics, so that we have those engineering and technology. Okay, so this is basically my picture here. Okay, this is me at one time when I was working outside there doing those a lot of automotive testing for the industry. So I did test, for example, the brake system and so on. So I did actually carry out this testing at the what we call this track, Johor Baru Pasir Gudang. Okay, so my outline will be basically the introduction. Banyak dah tadi kita punya Kristina dah terangkan pasal saya. And then I will go about a little bit on the automotive FKM. And then go into the introduction to vehicle dynamics. Okay, so basically what is dynamics here? The keyword here is dynamics. Okay, before we know that dynamic, saya akan cerita a little bit about vehicle. So, apa itu vehicle, apa itu dynamics? In order for you to appreciate this, I will talk about in specific about a car. So what is a car? And then what is a good car in the eyes of engineer? Okay, kita kan orang-orang technical, engineering and so on, kita kena ada satu uh, view on what will be considered as a good car. And then finally kita dah tahu apa itu kereta yang bagus. And then kita belajar how can we actually produce a good car. Basically, in order to produce a good car, kita ada dua step. The first one is we have to design. Okay, dalam proses design tadi, kita akan banyak menggunakan elemen science dengan mathematics to calculate a lot of things. Okay, kita juga banyak gunakan computer software macam CFD, macam finite element, macam CATIA and so on. Dalam proses membuat design tadi. Okay, so finally lepas kita buat design, kita kena verify and then kita kena buat validation. So kita kena akan buat testing. So that will be the process. So the first step in order for you to be able to produce a good car is to understand what is a car, then being able to define a good car, then being able to produce a good car. Okay, so finally ni saya nak relate a little bit apa yang dimasukkan vehicle engineering and design dengan what we call this STEM initiative. Okay. And then finally saya just go quickly to this satu projek yang pernah kita buat, and this was actually the first time the Faculty of Mechanical produced a car we call this EMOC, Eco Mobility Concept Car. Okay. Makna lain ada yang tersirat kat situ, banyak emosi yang tersentuh dan terlibat dalam kita membuat design dan develop this particular car. So ini nama saya di sini, Ramlan Kasiran, working now as a lecturer from 2008 sampai present. My subject that I've been teaching is numerical method, static. This is my favorite subject basically, and this is the most subject that the subject that I like most, that is dynamics. So basically, what is dynamics? In our life, hari-hari kita cerita pasal dynamic actually. Cuma kita tak pernah sebut itu adalah dynamics. Okey, sebagai pensarah juga saya adalah advisor kepada tim FKM UiTM. This was actually the team that I actually established in 2009 sebab kita nak masuk this Pro 2 Eco Challenge. So we did actually terlibat in that Pro 2 Eco Challenge from 2009 sampai 2012. And then kita juga terlibat dengan tim Android Artec. This is actually a team that actually participate in the Shell Eco Marathon in 2009 and 2010. Okay, so kalau you tengok daripada Pro 2 sampai Eco Marathon di sini, basically we started with the car modification for Pro 2 Eco Challenge. Kita modify the car. Pro 2 Eco Challenge, objective dia is actually to design, to modify the car so that kita dapat kereta yang paling jimat minyak. So that will be the challenge. Okay, dalam F1 in school, the challenge will be different. Kita nak kereta yang paling laju, try to break the world record, which is actually 0.916 second hold by satu team daripada Australia. Okay, so from simple modification, all done by the student of the faculty, kita progress into designing and fabricating of several single-seater car. Kereta yang cuma ada satu tempat duduk macam kereta Formula 1. Okey, kereta tu kita daripada panggil emosi, kita ada kereta solo, and then akhirnya kita produce kereta Formula SAE, Formula of Society of Automotive Engineer. Untuk makluman, FSAE dengan F1 e-School is more or less exactly the same. Format competition dia adalah sama. F1 e-School untuk pelajar-pelajar sekolah, but FSAE untuk pelajar-pelajar universiti. Dia melibatkan design and fabrication of vehicle, and then kita kena apply all those engineering fundamental yang kita belajar di universiti. Exactly the same. Okay, so selain daripada tu, saya juga actually advisor to several team from SMKS 9. Okay, so masa bekerja di luar sana, mostly saya terlibat dengan automotive testing, product development, and then R&D. All these are related to automotive discipline. Okay, ini gambaran dia lebih kurang. Ini basically masa saya buat kereta yang pertama. Yang di bawah ni adalah gambaran yang masa saya buat kerja-kerja di track tadi. This is Pasir Gudang punya track. Saya buat vehicle assessment. This is actually the last project saya terlibat dengan industri di luar sana. Kemudian masuk UiTM. So ini adalah kereta-kereta yang terlibat dengan Pro 2 Eco Challenge. And then kita design this single seater car. Okay. And then actually saya support juga team F1 in school. Inilah dia kereta F1 in school. So itulah cerita a bit history of automotive at the university. Ini tim senarai tim yang pernah saya deal with ataupun saya bantu dalam F1 in school dan juga aktiviti pelajar-pelajar universiti di Fakulti Kejuruteraan Mechanical Shah Alam. Ini kereta yang mula-mula kita buat. Okay, so kita modify dia, kita banyak modification. The objective is to design kereta yang paling jimat minyak. Dalam kes ni, kereta Mawi ni kita dapat lebih kurang 19 km per liter. Okay, ini gambar-gambar kejayaan after all the hard work. Kita buat kerja, kita usahakan dia, alhamdulillah kita berjaya. Nampak semuanya terhibur di situ. Ini kereta kedua yang kita buat. Kita modify. Nampak di sini student kena buat presentation on what are the modification on the car they have carried out. These are actually the barisan-barisan juri yang buat assessment ataupun penilaian. Okay. Ini juga kita menang alhamdulillah kita menang a few kategori. Okay, so ini actually saya tunjuk gambar sini parent. Okay, saya sangat-sangat appreciate parent-parent yang actually contribute, memberi sokongan moral kepada pelajar-pelajar dan juga kami semua dalam proses pembangunan anak-anak mereka. Okey, ini juga kereta yang kita buat tadi. Kita nampak ada parent di sini. Actually satu elemen yang penting di sini bila kita terlibat dengan aktiviti-aktiviti macam ni, bukan cerita pasal kejuruteraan saja, bukan cerita pasal sains juga. Kita juga develop good relationship antara pensyarah dengan pelajar. Okay, saya memahami apa yang pelajar punya expectation. So sampailah satu level tu, pesyarat pelajar tu membuat kenduri, pelajar perkahwinan dia, kan saya dijemput dan saya dengan Cik Anif pun datang sekali lah di situ. Yang ini ada satu pelajar perempuan ni, okey. So biasanya bila kita cerita pasal automotive, pasal mechanical ni selalu orang cerita pasal pelajar lelaki. Di sini saya nak share di sini pelajar perempuan juga berjaya di sini. Okay, saya nak encourage a lot more actually female student to join this engineering punya faculty. Okay, so finally from that kita go into this car and then this finally kita FSAE kita. Okay, ini gambar tim-tim. So saya rasa ini gambar Azrai yang dah sampai overseas sekarang ni dan hari ini alhamdulillah dia kembali dan join dengan kita. Ini tim-tim daripada SMK9. Yang ini adalah tim daripada sekolah sivil ke macam tu dipanggil Proton Eliters lah. This team basically pergi overseas lah. Alright, so that is a bit history and introduction on UiTM dan juga diri saya. So hari ini kita fokus into introduction to vehicle dynamics. In order for us to understand what is dynamic, what is vehicle, saya kata tadi saya fokus on this car sahaja, sebuah kereta. Semua orang pernah naik kereta. So can you actually define what is a car and then what is a good car and then how to produce a good car. Okay, so yang penting di sini hari ini kita cerita dalam from an engineering point of view. Kita nak define kereta tu good ataupun tidak good from an engineering point of view. Apa yang dikatakan kereta itu yang bagus dalam konteks engineering ataupun dalam konteks kejuruteraan. Okay, actually bila cerita pasal kereta yang bagus from an engineer point of view, it is related to what we call this dynamic qualities or dynamic properties of that vehicle. Saya akan cerita benda lah tu nanti. Okay, so what is a car? Semua orang tahu kan, dia tengok saja ini kereta ni ini lah sebuah kereta. But can you define what is a car? Okay. By definition, a car kita boleh define as a means, satu kaedah of transporting people. Kita nak transport people from one point to another point in a safe. Kita tu mesti selamat dan juga comfortable. A means of transporting people from one point to another point in a safe and comfortable manner. So from this definition, kita bertanya diri kita, how are we going to achieve this? How are we going to achieve or how are we going to have a car which is safe and comfortable? Okay, so let's say we want, so by definition tadi we want to transport people from one point, let's say from point A here, and then go to point B. This is typically, saya ambil very simple, yang you nampak hitam tu adalah dia punya laluan dia. So can we describe now? With respect to vehicle dynamics, the first thing that we must understand is what is the car, kita dah tahu tadi, and then what is the motion of the car. Masa dia bergerak from point 1 sini, the car will move forward in that particular direction. So that will be one of the motion. The car should be able to move forward. Kan kita ada velocity arah sini and then kita boleh accelerate, kita panggil dia acceleration in that particular direction. Let's say we want to go from point A to point B. Tiba-tiba kita terbabas, kita miss that, kita sampai di sini. So what do? Kita kena reverse. So that is another direction of the car. Dia kita juga boleh bergerak ke belakang. The point is, it is in the same direction. Sama ada ke depan ataupun ke belakang. So that is one motion of a car. So saya lukis di sini. Ini adalah satu arah pergerakan kereta. Kita ada dia punya velocity kat situ. Okay. And then kita dah tahu dia punya velocity. Kita tanya how fast. What is the top speed that the car can reach? And how fast dia boleh accelerate. Okay, bila cerita pasal this quantity, basically in that forward direction, kita nak tahu what is the top speed of the car. Contohnya sebuah kereta kancil, you boleh bergerak sampai 100. You ambil kereta Formula 1, you boleh bergerak sampai juga 100 km per hour. But bila kita cerita pasal dia punya performance, kita consider dia punya acceleration. What is the time taken to reach 100 km per hour? Okay, so kereta kancil mungkin ambil masa yang agak lama, 20 saat untuk capai 100 km per hour. Tetapi kereta Formula 1 mungkin ambil masa dalam 2 ke 3 saat sahaja. Soalan dia, kenapa? Macam mana benda alah tu boleh berlaku? So as engineer, we should be able to apply science dengan matematik to explain this properties. Dia punya velocity dengan acceleration. Ini yang dipanggil kinematik di sini. Bila kita cerita pasal motion, kita panggil dia kinematik. So kinematik is actually one part of dynamics. Dynamic basically is divided into two, kinematic and kinetics. Kita cuma yang di sini kinematik, kita cuma cerita pasal motion. So that is the motion. Okay, so saya kata tadi kereta ni terbabas di sini. So dia patah balik. So dia pergi balik dekat that point, then what happen? Kereta tu akan bergerak, dia akan turn to that direction, and then sampai this point here, dia akan turn to that direction. So that is actually another motion. Okay, so basically saya kata kereta tu akan bergerak arah ke kiri. So that will be the first one here, and then dia juga boleh bergerak ke kanan. So that is another motion. So dari sini kita kata kereta tu boleh bergerak arah macam tu. So you can have velocity in that direction plus acceleration in that direction. So those are basically the motion component. Okay, performance wise, bila kita kata kereta tu bagus, dia mesti cepat, dia mesti laju. Bukan setakat laju bergerak jalan lurus ke depan, masa corner juga dia kena laju. You bayangkan kereta Formula 1, kalau dia pusing dekat bulatan masjid, mungkin dia boleh pergi sampai 200 km sejam. Tetapi kereta kancil tadi mungkin bergerak pada 60 km sejam. So, quantity macam tu, the speed, the acceleration tadi adalah quantity yang describe the quality of a car. Saya kata tadi, dalam konteks from engineering point of view, how do we define a good car? Okay, a good car mesti boleh dengan cepat. These two quantity here, motion in these two direction di sini, yang ke depan dengan kanan kiri adalah what we call the handling qualities. So bila cerita pasal kereta, kita cerita the handling qualities. How fast the car can go straight, how fast the car can take corners. This is what we call the handling qualities. Alright. So bila kita buat design, when we design the car, apa yang kita suka kita kena maximize. Kita nak, maksudnya is this qualities tadi kita nak tinggikan dia. Kita nak dapat ada acceleration yang besar, kita nak ada yang top speed yang besar. So kita kata kita maximize the quantities that we want. Kalau kita dapat yang paling tinggi, itulah yang bagus dari segi dia punya handling. But don't forget, masa kita bergerak tadi, kereta di sini mungkin dia langgar lubang kat sini. You can have pothole on the road. Apa berlaku? Kereta tu akan bergerak ke bawah. Ke depan sikit dia jumpa satu road bump. What happen? Kereta tu lalu kat sini, dia akan bergerak ke atas. So that will be another motion. Bergerak ke atas dan ke bawah. So that is V in vertical direction, and then you have that acceleration in that vertical direction. So soalan saya kata tadi kereta must be comfortable. Now people is a medium of transporting people. So we sit inside the car. Do you feel comfortable kalau kereta you bergerak ke atas dan ke bawah? This is what we call the vibration di sini. We don't like this. Kita nak kereta yang orang kata Bila kita jalan, dia duduk dalam tu, langgar lubang macam mana pun, langgar lopak, langgar bendul ke apa, kita macam duduk dekat kita punya living room. Kita tu tak bergerak, maintain. Okay? So ini benda yang kita tak nak tadi. We don't like this. So in that respect, bila cerita pasal kereta punya performance, kita nak minimize this. Benda yang tak nak ni kita kena buang ataupun kita kena kurangkan. So motion yang in this vertical direction, this is what we call the ride qualities. So kita simplify that dalam konteks vehicle dynamic from an engineer point of view, the quality of the car is defined by these dua benda, by the ride and that handling qualities. They must be very comfortable and then they must be able to go fast, go straight fast, ambil corner juga laju. So inilah kereta yang kita kata, kereta yang kita nak. So that is from the point of an engineer, a good car is having these two qualities. Okay, saya belum cerita lagi apa yang sebabkan benda ni bergerak tadi. We have this velocity, we have this acceleration. Okay, untuk completekan dia basically, okay, kereta ni juga masa you tekan brake apa berlaku. Kita relate dengan apa yang kita rasa. That is hukum alam dia. Bila kita tekan brake, dia akan menjunam, dia akan dive macam tu. Bila kita akan accelerate, kita rasa kereta tu sporting macam tu. Kita terdongaklah ke belakang macam tu. So kita ada satu rotation macam tu lah. So, ini dipanggil pitch. Okay. And then what happen? Masa kita corner juga, kereta tu juga boleh, bila you duduk dalam kereta, bila corner kan kita tergerak ke tepi macam tu kan. Kita bergerak kanan dah ke kiri. You know why? Sebab kereta tu kita kata dia boleh roll. Kereta tu boleh roll, dia pusing sengit macam tu. And then dia juga boleh bergerak macam tu. This is what we call yaw. So sebenarnya sebuah kereta tu ada 6 jenis motion. Yang 3 in straight line tadi, this is what we call the linear motion. And then yang rotate tu is what we call the rotational motion. That is very common. Dalam dynamics, motion tu terbagi kepada dua, yang sama ada dia punya translation, pergi macam tu, and then satu lagi yang boleh rotate. We have this. So kereta tu ada 6 jenis motion. Alright, so that is basically the kinematic part of this vehicle dynamic. The next question is, sebelum saya pergi kat situ, saya go in very general. Sebelum saya pergi ke performance of an F1 car, F1 in school car. Sebab apa? Sebab kita cerita pasal 4x4 juga. Kita juga ada 4x4. Alright, apa beza 4x4 dengan F1? 4x4 will be having all this motion. Dia boleh bergerak ke depan, ke belakang, ke atas, ke bawah, and then dia boleh rotate about all these 3 axis. Itu 4x4. Tetapi kereta Formula 1 in school, dia tak perlu belok ke kanan, belok ke kiri, tak boleh bergerak ke atas ataupun ke bawah. Jalan dia very smooth. Okay, so dalam konteks tu, Formula 1 tu cerita pasal pergerakan ke depan sahaja. Dia tak pernah reverse pun. Dia gerak ke depan sahaja in one direction. Okay, so kalau tanya orang awam tadi, kalau dia tanya people at the public kat situ, dia kata macam mana? Macam mana kereta tu boleh belok? Dia akan kata sebab ada steering. Alright. Kenapa kereta tu boleh bergerak ke atas masa langgar bendul? Sebab dia ada absorber and damper and the suspension system. Kenapa kereta tu boleh bergerak ke depan dan ke belakang? Sebab dia ada dia punya engine yang actually propel the car forward. And the engine actually will produce force ataupun torque transfer to the wheel, dia akan bergerak ke belakang. And then nak to slow down, what we do, kita kata kita apply brake. All these things, all these yang saya sebut, brake, steering, suspension, semua tu adalah what we call the mechanical system. Ini peranan engineer kena design. Dalam proses nak design tadi, kita kena belajar baliklah dia punya science, mathematics, engineering dengan teknologi. Alright. So we go to the next part. So saya fokus now into F1 in school because we don't have this type of motion. Kenapa tak ada? Sebab kereta tu bergerak in straight line, dia tak perlu belok. Okay, dia jalan dia straight, rata, dia tak ada bump and so on. That is no vertical motion. Sebab kereta Formula 1 cuma boleh bergerak straight ke depan. Next question is, macam mana sebab apa dia bergerak ke depan? So this is what we call the relationship between the force and that motion tadi. So bila cerita pasal motion tadi, ada dua quantity, that is velocity dengan acceleration. Okay, so soalan dia is, macam mana kita nak gerakkan benda tu? How can object that move? Saya kata tadi, dalam kereta tadi kita ada enjin. So mungkin ada enjin kat sini, so dia pusing kat situ, dia akan produce torque, dia akan transfer dekat ni lah, dekat dia punya wheel kat sini. So you akan have this what we call the tractive force, FT. The tractive force yang bergerakkan dia ke depan. Okay. So what do you know about this car? About this force? What do you observe? Okay, so you bayangkan dia, kalau you tendang bola dengan kuat, dia akan pergi laju. Kalau you tendang bola dengan perlahan, dia akan pergi dengan perlahan. Kalau you tendang bola ke kiri, dia akan pergi ke kiri. Kalau you tendang bola ke kanan, dia akan ke kanan. Itulah hukum alam dia. Kalau kita apply force ke depan, dia gerak ke depan. Lagi kuat kita apply force, lagi laju kita pergi. But the value of, saya kata lagi kuat tadi, is actually defined by this. Berapa besar enjin boleh produce that torque ataupun power. This force, dia punya limit is, what is the value or the amount of engine power ataupun torque yang kereta tu boleh ada. Dia ada limit dia. Alright, dalam konteks F1 in school, so the idea dia tadi, bila kita design, kita nak buat dia enjin se-powerful yang boleh, kita letak enjin sebesar yang boleh. Tetapi dalam F1 in school, kita tak letak enjin macam ni. Kita cuma letak satu compressed oxygen, carbon monoxide di belakang ni, and then dia punya value dia lebih kurang 8 gram di situ, and then dia letupkan dia situ, the canister tu tadi kan, dia trigger, dia letup, and then dia apply force very quickly, sekejap sahaja. Macam contohnya you pukul bola tenis, you just tap macam tu kan, bola tenis tu akan bergerak. So that will be the initial, what we call the impulse force yang apply over a period of a very short time, and then the car will accelerate. Okay, so dalam konteks F1 in school, kita tak boleh buat apa, we cannot actually design different engine and so on. Semua team gunakan that force yang sama. Okay, so saya tadi, the performance of the car is defined by how fast it can go. What is the top speed? So now the challenge is what we can do. Yang ini bahagian engine tadi, power plant kita tak boleh buat apa. Okay, maksudnya dia punya FT is the same. For every team in this competition, that FT is the same. Dia ada satu value as governed by that rule and regulation, because this is actually generated by this. So now the point is, kita kena faham, okay, bila kereta tu bergerak, dia bergerak dalam medium apa yang dipanggil udara. Okay, so can you bayangkan dia tangan, bila you berjalan dalam udara, you rasa bergerak, you macam ada resistance, dia akan tolak kita ke belakang. Kalau you berenang dalam ataupun you jalan dalam air, you akan rasa lebih susah nak bergerak ke depan. You know why? Because there will be what we call the drag force. Air itu tolak kita ke belakang. Okay, so in that respect, masa benda ni bergerak, sebab kita lalu medium air, kita ada force yang tolak dia ke belakang. This is what we call the drag force. Drag force in the opposite direction. Okay. So, nak fahamkan dia macam ni, you senang saja, you bayangkan you ada satu kotak macam ni. Kalau kita letak dua orang, Ali dengan Mutu kat sini. Yang di sebelah sini, kita ada Acong. Ali, Mutu dan Acong ni. Ni So, agak-agak you lah kereta ni akan bergerak mana. Katakanlah semua ni mempunyai kekuatan yang sama. Dua orang gerak tolak ke kanan, seorang gerak ke kiri. Definitely the car will move in that particular direction. You know why? Sebab kita akan jumlahkan force ke sini, ke kanan, tolak yang ke kiri. Itulah dia punya what we call the resultant force. Okay? So the idea dia di sini, masa kereta tu bergerak, there will be what we call the resistive force yang menentang dia, yang melawan dia. Being an engineer, bila kita nak design, we should be able to identify these forces. Kalau kita boleh reduce this, kalau kita kata, if we can reduce this FD, kan? So we will have basically, kita jumlahkan the force tadi, the net force forward will be higher. Because that FT is constant, kalau you boleh reduce FD, maksudnya the net force will be higher. So the car will accelerate faster. And then from experience, satu lagi. Okay. Kalau you ambil satu roda macam tu, katakanlah you ambil satu tayar kat sini. Okay. And then you take a big tire and small tire, satu lagi berat, satu ringan. Mana senang nak roll dia, mana senang nak rotate dia. You try to push a wheel kat situ. Basically, the larger the wheel, the harder it is to move or to rotate. Itu hukum alam dia. Okay? So, di sini serupa juga apa berlaku masa kereta tu bergerak, roda tu akan berpusing. Okay. Roda depan berpusing, roda belakang berpusing. Soalan seterusnya is, masa dia berpusing, dia akan perlukan some force kat situ. So, maksudnya that FT juga, force yang available tadi akan digunakan untuk melawan force daripada sini. Kan saya kata tadi, di sini, kita berapa force required to roll. Kita nak roll, maksudnya kita nak golekkan dia ke depan. This is what we call that rolling force. Okay, that rolling force. Okay. So, kita ada source of force yang sama, FT, masa kita nak gerak ke depan. So, these are all forces yang melawan dia. FD dengan FR. Clearly, kalau kita boleh minimize that FD dengan FR, we will have higher acceleration. So, the next question is, macam mana kita nak capai itu? Okay? So, bila cerita pasal tadi, saya sebut, the larger the force, the larger the acceleration. You apply force to the left, dia gerak to the left. You apply force to the right, dia akan bergerak to the right and so on. Basically, bila kita pasal force ni, kita ada tiga benda yang kita kena specify. What is the magnitude? How large is the force? And then kita kena specify dia punya arah dia. Kat mana kita arah mana kita apply. Dalam konteks macam ni tadi, kita apply force ke depan, tetapi ada force yang lawan dia ke belakang. So, dia punya total force, the resultant force become less. And then kita kena specify kat mana kita apply the force. So, bila kita cerita pasal motion tadi, so motion ni adalah disebabkan oleh force di sini. Okay, semua motion adalah disebabkan the force. So, the relationship between force and motion, this is what we call kinetic, the study of the effect of forces on a rigid body. Okay. So, konteks dia, idea dia di sini is, boleh tak kita quantify semua forces ni? And in order for you to actually produce the fastest car, the fastest F1 car. So, inilah dipanggil vehicle dynamic, consisting of kinematics, that is study dia punya motion, dia punya velocity and acceleration. And then kita relate dia dengan force. What are the force required to cause that motion? So, ini yang pertama, bila kita nak design, kita kena identify all these forces. So, kalau you baca buku, kita buat study and so on, force yang ke belakang, saya letak warna merah tu, force yang tolak dia arah ke belakang. So, this is what we call negative force ataupun resistive force. For force yang gerakkan dia ke depan, this is actually the tractive force. The net force is kita tolakkan dua tu, so the value will actually equal to MA. So you have now the net force FR, the net force that is equal to MA. Ini Newton second law. Semua kita dah belajar di sini. Okay. So what do you learn from this? Okay. So kalau you tengok this formula here now, that's why bila kita design, kita apply mathematics and science. Kalau kita M dia itu kecil, maksudnya dia punya acceleration dia akan jadi besar. So from here you can have now A is equal to F R divided by M. Alright, so what do you see here? This is what we call the inversely proportional punya relationship. Kalau mass dia lagi kecil, dia punya acceleration dia akan jadi besar sebab FR tu adalah constant. So dalam konteks F1 in school, kita apply this fundamental, kita kan bila kita buat design to capai kereta paling laju tadi, kita kena minimize the mass serengan yang mungkin. Lagi ringan lagi bagus, dia will accelerate faster for the same amount of attractive force. Alright. So and then kita will look into, sebelum saya terlupa, bila kata kita minimize tadi, kita kena comply lah dengan rule and regulation. Kalau dia kata minimum 50 gram, make it 50 gram. Jangan sampai break the rule. Nanti you disqualify. Alright. So dalam design kita ada rule dengan regulation yang kita kena follow. Ini dia panggil dia punya design constraint. Okay. And then kalau you go into this FD from kita punya reading, kita boleh basically understand there will be one formula here ni. FD is equal to half rho CD, yang ini tak ada ni, half rho CD A V squared. Apa maksudnya ni? The higher the velocity, bila you increase that V, FD akan increase. AE actually dia punya cross-sectional area. Kita potong kereta ni, kita tengok area dia besar mana. Okay. So angin akan tiup melalui that cross-sectional area. Lagi besar area tu, lagi besar dia punya force. What happened here? That is CD. What is the drag force? That is the drag force. For any shape, there will be this value, what we call the coefficient of drag. The larger the CD, the larger will be the force. So in this context, our objective is to minimize this loss. Benda yang kita tak nak, kita nak eliminate. So macam mana nak kena eliminate? Kita kena faham this formula here. What you see here, kalau V besar, dia besar. A besar, dia besar. CD tinggi, dia makin tinggi. So dalam kita buat design, that's why you have this only finite element, sorry, dia punya CFD, you kena paling low CD. Nilai dia mungkin ke 1.2. So what is the limit right now? I'm not sure dalam konteks F1 in school. Try dapatkan dia serendah yang mungkin. Bila you dapat dia rendah, FD dia akan jadi rendah. And then you have that is A here. Okay. A, boleh tak kita reduce that surface area? Maksudnya kita buat kereta tu very streamline. Kita kena dapat ni. So inilah apa yang sepatutnya engineer bila buat CFD analysis ada dalam mind. Bila buat design of the car, inilah benda yang kena ada dalam kita punya mind. Nak dapatkan bentuk dia tadi, kita kena fikir objective is to minimize that drag force. How? Reduce dia punya area. Reduce that dia punya CD. Yang rho di sini, this is what we call the density of air. Yang ini kita tak boleh buat apa. Semua kereta bergerak pada medium udara yang pada yang sama, pada tempat yang sama. Nilai dia lebih kurang 1.22 macam itulah. Dia tak boleh ubah. Alright. So satu lagi elemen di sini is this is what we call that FR here. This is bukan frictional loss. This is what we call that rolling loss ataupun rolling force. Okay, that is equal to CR here kali dengan M kali dengan G. So what do we understand? That M is mass of the wheel. Okay, maksudnya is saya kata tadi roda yang lebih berat lebih susah kita nak tolak. they will produce a lot of FR di situ. So bila kita buat design, kita kena set objektif, kita nak wheel kita serengan yang mungkin. M will be the lowest possible. CR ni sepanjang cerita, this is what we call that coefficient of rolling resistance. Okay, saya tak nak sebut tu. So in general, for the same amount of force FT coming from that canister, your car will be actually losing force through this FD dengan FR. Kan bila kita jumlahkan dia, the net force, that will be the things that the force that will produce that acceleration. So bear in mind, inilah dia what we call that vehicle dynamic study on the forces and the effect on that motion. What is motion? Velocity and acceleration. Okay, so kita dah clear kat sini and then we go into bila nak kata kita nak design a good car tadi, kita kena consider all this. And then first thing is we must have the objective. So, kat sini saya kata sini kita gunakan elemen STEM tadi. Fahamkan sains dan gunakan matematik untuk kira segala benda yang ada dalam sini. Okay, bila nak design tadi kita kena ada set objektif. Contohnya kita set, this is the fastest car. So, kita datang satu persoalan di situ, how are we going to beat this? What we can do? What we can do? So, bila kata what we can do, ini saja yang you boleh buat. You boleh modify ni. That's why you need those apa ni? CFD tool and so on. Bila design, you must have all this. Satu lagi yang saya tak sebut in detail basically antara surface tu, when the wind is actually flowing through, kita ada juga what we call that surface friction. Konsep dia is, kalau you ada surface, you nak slide macam tu, lagi kasar lagi, besar dia punya frictional force. So, dalam konteks tu, bila you design nanti melibatkan dia punya finishing, make the surface very smooth. Okey, roda ni juga berpusing di sini. Macam mana roda tu berpusing? Dia duduk atas satu shaft macam tu. Alright.
Prof. Ramlan?
Ya.
Hi, I'm so sorry to cut you off. I just want to remind you, you have 5 more minutes until your slot is finished. I'm so sorry.
Alright, it's okay. Okay, I'm on time. Okay, so bila cerita pasal benda yang berpusing tadi, dia akan rotate. Dia rotate atas shaft tu, dia rotate, dia akan ada friction. So, satu matlamat dia bila cerita pasal benda, kita kena letak ball bearing. So, ada dua kat situ, frictional punya friction, and then you have that rolling surface punya friction. You have this in your mind. Okay, so kita nak beat tu, itulah yang kita boleh buat. So, how do we do this? Basically, kita gonna apply this. Engineering principle. Creative application of scientific principle to design or develop something for the intended function. What is the intended function? What is that something? Kita nak produce car. What is the intended function? To beat that. Kita kena ada set that. In order for you to be able to do that, saya kata tadi, you kena faham apa itu F1 car, how does it work dynamically, and then how to make it work. Kita work along understanding all those things behind this. Gunakan STEM kat situ. Okay, so design ada proses dia macam ni lah. Basically starting from that design, and kita buat verification, kita buat design tu betul ke tak betul, and then kita buat validation. Yang ini cerita detail kalau kita buat class on this particular subject nantilah. So finally, I just want to talk about the vehicle that we have designed at UiTM. Ni kereta yang kita buat pada satu masa tu. So kita ada objektif, fuel efficiency. So ini yang kita kata kereta yang kita nak buat, kita kena specify. Ikut rule and regulation. Sama juga macam F1 school ada rule and regulation, kita kena follow. So kita start dengan initial idea, kita generate that idea. Objektif kita dah set. Okey, kita datang dia punya konsep. Yang ini actually kita sketch pada tahun 2010 dulu by somebody from our faculty. Angan-angan masa itulah. So finally kita dapatkan dia punya car konsep, kita work along. Dalam proses ni nak buat kereta yang paling jimat minyak ni, kita apply apa yang kita belajar. Banyak kita pasal science, mathematics and so on. Basically it's from the observation. Okay, from the observation, fenomena alam tadi, and the people come up with that formula to describe that. Contohnya FD tadilah. Kenapa datangnya half rho CDA V square? That is from observation. Kita observe, kita buat eksperimen, sampailah kita develop that formula di situ. And then kita come up with that body design kan? And so on, ada constraint dia. Nak buat sebiji kereta tadi, nak buat curve yang susah, kita buat yang simple macam ni. Okay, so go to that and finally kita sampai produce. Kita dah buat design tadi, kita buat CFD to verify balik apa yang kita buat. And then finally kita buat testing tadi. That is to validate. Design, verification dengan validation. Betul tak apa yang kita design tadi? Okey, ini proses pembuatan dia, cerita pasal body shell design. Banyak tool yang kita guna. Macam ni contohnya kita buat verification. The stress is we have to apply the engineering skill. Pelajar-pelajar ni buat ni lah mula-mula dulu. Okey, so ini aktiviti pelajar. Kita gunakan kita punya creativity and innovation di sini. Bukan macam dalam sebuah kilang kereta, they have complete tool and equipment. Kita guna apa yang ada, so we have to be creative. Dengan juga innovative in solving problem. So ini kereta kita, chassis dia. Kita gunakan tool buat final element analysis to make sure it will not break or bend and so on. Okay, bila kita buat design chassis, kita ada juga buat dynamic analysis masa braking, masa accelerating, masa cornering and so on. Safety, kita ada this impact actuator lah basically nak absorb the impact. Dia kalau berlaku impact and so on. So kita buat simulation, gunakan all these tools. And this is engineering, this is the technology that is available, we use that. What we want to, untuk capai apa yang kita nak. Ini contohnya dia punya suspension. Kalau cerita pasal 4x4, kita kena design dia punya suspension. Okay, to absorb that vertical movement. Dan juga to control dia punya steering semua tadi. Kita buat all those analysis. Okay, so finally kita gunakan whatever tool yang ada buat sebelum kita finally produce sampailah kita keluar this. Saya stress software is just a tool. Brake system, komponen kita kena datangi macam 4x4 you must fikir macam mana nak slow down that vehicle. Okay, so ini adalah contoh-contoh yang pelajar buat and then we have the steering system. So finally inilah lebih kurang gambaran kereta tanpa dia punya body shell complete, you nampak everything have this. So inilah kereta kita akhirnya yang kita buat. Alright, itulah dia tadi lebih kurang pasal vehicle dynamics. The idea is kita nak belajar STEM through vehicle engineering design in a fun way. Maksudnya kita buat kerja tu kita belajar. Sambil kita belajar kita buat apa? Kita buat the fastest toy, the fastest F1 car in school. Dalam proses tu kita gunakan STEM. That's why saya kata tadi kita kena buat tu kita panggil objectively. Kita kena ada objek apa yang kita nak capai. Quantitatively kita kena quantify what we want to achieve in term of value tadi through equation yang kita gunakan tadi dengan mathematics. Bila cerita pasal equation, dia relate apa? Science. Contohnya physics and so on. Okay, objectively ada matlamat, successfully and then repeatedly. Kita boleh ulang. Okay, bukannya orang kata by luck. Kalau 10 kali kita buat design, 10 kali kita akan successful. Why? Because kita follow certain design procedure. Ada step dia, 1, 2, 3, 4, 5, 6, 7 design process. Okay, so kita boleh share kita punya pengalaman senior kepada junior nanti. Apa yang you all dah belajar, senior dulu, Mr. Azrai. So, you mewarisi apa yang dia buat. And then we try to improve. Alright, so itu saja untuk hari ini. Terima kasih semua. Kalau ada soalan, okay, Erina, saya dah habis saya punya presentation. Kalau ada soalan, saya ready to answer any question. Alright, thank you.
Wow, Mr. Ramlan, thank you for the very informative talk. Our Q&A slot will begin now. Jadi, para hadirin, you are most welcome to press the raised hand icon in the Google Meet if you have a question to ask. You could also write your question in the Meet chat or Facebook Live comment. We'll give you a few minutes to write down any questions you have for Mr. Ramlan.
Okay, any question?
I can see someone raise their hand, so perhaps that person would love to open their mic and ask directly.
Silakan, silakan.
Ada yang raise tangan ke dekat Google Meet ni? Boleh tanya soalan tentang pembentangan Prof. Ramlan tadi?
All right, so I assume there is no question. Now let's move on to our next slot with speaker Mr. Azrai Azmi, a former student of SMT Section 9 Shah Alam that has also participated in this prestigious F1 in Sports competition in 2013 as Team Infinite 9, Team Manager and Design Engineer. He has since deepened his interest in the engineering spectrum and now has completed his education with a Bachelor of Engineering in Mechanical Engineering with Aerospace at the University of Southampton, United Kingdom. Currently, Mr. Azrai is an intern at General Electric and will be pursuing his Master of Science in Aerospace Vehicle Design at Cranford University, the United Kingdom, starting this March.
Hi everyone. Good morning. Assalamualaikum. Teachers, professors, students, parents. Before I start, I actually saw a question on Facebook for Professor Ramlan. If you want to answer this, adakah downforce diperlukan dalam pertandingan F1 in schools? So before I start, I thought maybe that was a good question to answer.
So Azra, you asking me, that is the question, right?
No, someone on Facebook asking on the Facebook
right.
Live. Yeah.
That depends on the situation. How do you define that downforce? Definitely, if you want to minimize that rolling force, just now we have that rolling force. If you can make your vehicle sort of floating, so you have remember that FR is given by CR M multiplied by G. That is actually CR multiplied by W. So if you can reduce that downforce, actually you sort of that reduce that mg, so the fr becomes less. Okay, so but the problem if you reduce that downforce, can you actually balance the front and the rear downforce? Otherwise the car will just fly. You must have sort of very balanced downforce, meaning to say you have this is F1 car here. If you can reduce that force downward, remember that rolling force is equal to CR multiplied by that W, which is actually N there. You cannot do anything on that. What you can do is actually you leave that. If you leave that, meaning to say that CR here, so that W here become less. So you will reduce that loss. F loss is equal to CR multiplied by that W. The problem is that downforce will have two components. One is in the front here, one is at the rear here. Can you actually balance that? Meaning to say that downforce at the front here is equal to downforce at the rear. What happens if it is not? If you want to make the car actually balance, they must be the same. Both is sort of floating on the air here. Sort of macam kereta api tu elevated kan? They can fly macam tu. So you can reduce that rolling loss. But the problem is, in order for you to achieve that, you must make sure that that front and the rear downforce is the same. If the rear is slightly higher than the front, what happens is just macam tu. So what happens when it's actually accelerating, it just fly off. Kan? Serupa juga, kalau downforce kat belakang depan ni besar sini, kan? Dia akan lift dia punya rear. Possibly dia akan roll macam tu. And dia akan roll, pitch macam tu. That's why to make sure that your car will go in straight line, dalam F1 in school dia letak satu macam nylon rope bawah tu. And because you cannot ensure that the car will just go without actually causing that to fly off. To make sure the car is actually guided by that rope. Okay, so downforce ini satu benda yang sangat interesting, kita boleh play around, but you have to be orang kata be careful. Make sure what is the center of pressure, what is the center of mass, what is the value front and rear. Alright, okay Azrai.
Yep.
All right.
Okay.
Thank you so much, Prof, for that answer, and thank you to whoever that asked that question. And wow, Azrai, balik kepada case study, you have such an amazing achievements here. Would you like to take it from here and share with everyone your journey from being involved in F1 in schools thus far?
Okay. Thank you very much, Irina and Christina. So without further ado, I'll just get straight to the point. So like Christina introduced me before just now, I am a former F1 in school student back in SMK Section 9. After that, I did my A-levels at College Hassan UiM, then went to
I'm sorry, Mr. Azrai, but your connection is kind of bad. Can you ulang that, please?
engineering. So now I'm going to try. Is it still bad right now?
Tadi it was kind of lagging. Could you ulang what you said before this?
Okay. Okay. So I'm just gonna get straight to the point. So, like Christina introduced me just now, I am a former F1 in school student also from Section 9. That was back in 2013, so it's about 7 years ago. I did my A-levels after that and then went to university and then I'm going to do my master's later on. So far so good. Is it clear? Just stop me if you need me to repeat
Yeah,
anything.
yeah, it's perfectly clear.
Okay, cool. So you can see my screen also, just to make sure.
Yes.
Okay, thank you. Okay, so here's what I'm going to be talking about. So how it started all the way back in 2013. And then I'll tell you about my experience on how things have developed from F1 to what I've been doing now. So that'll be in the computer side like CFD, like Professor Ramlan mentioned, the hands-on bits where I had to build things myself, and then the people relationships, not bits, you know. So the relationships that I've built over the years from what I've learned from F1. Okay, so how it started back in 2013 is that my team was called Infinite Nine, and the first time that Section 9 participated was back in 2008, if I remember correctly, and it was still with Puan Kashnani. So from 2008 to 2012, there was no participation from us for this. So we built a team, Infinite Nine, and then 7, 8 years later on, Section 9 is still doing it every year, and they're getting better every year. And you see the pictures that I'm about to show you, and see how the school has improved quite a lot since our time. It does make me a bit envious, but you know, that's the whole point of it. You guys are supposed to be getting better every time. So back in 2013, this is how our booth was. Okay, so you can see this is during the regional event, and it was quite not very good looking. Let's be frank with that. So, but you know, we just had to work on it. So this is the rendering I did of the car. So if just now Professor Ramlan mentioned about the wheel bearings and the rotating wheels and so on. So these are the different elements that goes in car. So if you can see what I'm showing in the camera here, I actually have my car back from the nationals. I still keep it. So we have the rotating wheels over here, wheel bearings, and then we have the 3D printed rear wings and front wings. So these are PLA material, I think, if I remember. And then talking about the downforce thing just now, so that the car doesn't fly off or anything. Yep, you do need to make the car balanced, not going too much front or too much back, because if you do it too much front, you can see how the area also increases. Over here, the area is minimized. If it's too much front, also the area increases. And then we have the tether line over here. the two circle lines over here. So that's where the nylon string goes through, so that the car doesn't just fly off the track. Okay, so cool stuff. So this is the rendering of the car we have, uh, and then this is our national booth. So you can see how we started from the regional booth.
Mr. Azrai, your connection is getting bad again. I'm so sorry.
Hold on. If you can hear me, uh, hold on. Yeah, my not good at all. I already, to be honest, I told my family to turn off their Wi-Fi already on the devices. Uh,
Don't
can you
worry, it's
can you hear me
perfectly
now, or is
understandable.
it still bad?
It's okay now.
Is
It's
it okay
kind
now?
of it's kind of okay. You
Okay.
can proceed.
Tell me where you lost me. Where do you lose me?
You were just introducing back in 2013 or something. I'm not really sure.
Ooh, did you get to? Did I show you the car already? The one I have now. Did I get to show that?
Not quite in detail. Maybe you can proceed from there.
Mm, okay. So you can see my screen now. How there's four different pictures, right? Um, so the bottom left is the different parts of the car, and this is how the car is in real life. Okay. I'm going to try and connect to a different Wi-Fi right now. Okay. So just in case I get disconnected for a while. Give me one
It's
second.
alright. Take your time. Don't worry about it. Sorry for the technical difficulties, everyone.
Okay. Okay. Am I still connected fine right now?
Yes.
Yes, perfectly
Okay,
fine.
cool. So this is the car which I still have from Nationals. Okay. So wheel bearings are in this wheel. So just comparing with the slide that I have here. So this is how it is in real life. And then adding on to Prof. Ramlan's explanation just now, that you don't want the car to go too much high or too, tilting down from the imbalance of the downforce. So that's why we have the tethers over here at the front and at the back. So that's where the nylon string goes through, so that the car doesn't just fly off the track. And then from this angle, you can see how the frontal area is small. So if it's tilting too much, you can see how the area got bigger compared to this. So that's why you don't want that. It would just increase the drag. So just to add on to the answers of the downforce just now. Okay. So next, this is how I experienced F1 last time. So it was never a smooth ride from the start. Yes, we did get to nationals. Yes, we did get second place. Yes, we were supposed to represent Malaysia, but then because the competition clashed with our SPM, so we couldn't go. And it was supposed to be in Abu Dhabi, so that was quite sad. Um, but yeah, it was never a smooth ride. All of it was a lot of hard work every day, and it all built up slowly. One thing led to another, and this is what I'm going to show in my in the coming slides, that what you're doing now, the results are not going to show tomorrow or in a month or even in a few months. So expect it to come in the years. So you really do need to put the work into it. You will cry, so don't worry, I did that a lot. I'm still 23, I'm still learning. So if you have any students over there who want to break down, you can break down, but just get back up on your feet later on. So I like this quote actually. Opportunities come to those who prepared. And if anyone watches Haikyuu, the anime, then you probably know where this came from. Um, so yeah, I'm just trying to show also that just because I'm doing engineering doesn't mean I cannot have fun. I do have fun watching anime and playing volleyball and things. So okay, moving on. First, we have this part, the computing bits. Specifically about CFD and analyzing the design of the cars and all that. So yep, honestly, it is pretty hard. I didn't understand 100% what was going on in school, or well, I thought I did, and then I came to university and I realized I didn't know anything back in school. But the result is cool. You'll see what I mean. Okay, so this was my design of this car actually. So you can imagine all the contours and flows going through there. And I can tell that this is a very coarse mesh already. I'll show you what mesh means later on. So you can see how most of the drag or really a lot of grid at the front there. Sometimes I don't know why I designed the front wing like this also. Um, yeah, so this is bad. I don't like that. But anyway, moving on. Where's the turn that off? Okay, and then over here is what happened after F1 in schools actually. So in about, I think it was in 2015 or 2016, I had this attachment with RTEC in UiTM actually, because for our nationals in 2013, we started collaborating with UiTM, and that's where the relationship has just gotten stronger even until now. So even Professor Ramlan taught me a lot of things when we were collaborating, Professor Hanif, Dr. Wan, and Dr. Ami also. So this is me working with Dr. Ami. So like Professor Ramlan was showing just now, they had their Formula SAE car. So this is one of the cars actually, and I carried out some CFD on it. I presented it to Dr. Ami. The objective of this, like objectives, like Prof. Ramlan said, is something you always got to look at when you're designing something. Was that we wanted to improve the design of the side pods to make sure the air intake to the radiator was as as efficient as possible. So I built up from a car which fit my hands going 70 kilometers an hour on the small track. And we had this car which is going about 100 something kilometers an hour. So I had to do some CFD on that. And then you can see how the mesh, you can see the colors, how it's smoother now compared to the previous one in F1 in schools. And then I moved on to university and I did some CFD for my final year project. And this is the SpaceX Starship design. So if anyone knows SpaceX with the landing rockets and stuff, I've always been interested in that. So this is what you call the mesh. This is a very coarse mesh. I understand Dr. Azli is here, and he'll probably be judging me a lot on the CFD because I know he has a PhD in CFD. Um, so it started off like this, and then I improved on the mesh. So you can see how the mesh has gotten finer at some parts and it still stays coarse at other parts. So this is the things that I've developed since F1 on how to carry out CFD, in a better way. And for context, the F1 car was our F1 schools car goes at 70 kilometers an hour, and then I was working with RTEC. That one was 100 plus kilometers an hour, and then my project CFD here, this one is traveling at about 25,000 kilometers an hour. So because it was going all the way to space. And you can see the results over here with this much smoother colors, and you can see how the shock waves are happening. So these are the contours of Mach number. So Mach is the speed of sound. I mean, Mach 1 is speed of sound. So Mach, any number after that is just relative to the speed of sound. So what's happening here is that at the shock wave, you can see where all these curves are happening. So a shock wave happens at any part where there's a turn in a flow of air, as long as it's fast enough. So this is the kind of things that I've developed back from this. So this one was like, oh, cool. I thought that was cool. And then I went to this and it was like, oh, I still don't know a lot of stuff. So yeah, that was the things that I've learned on from CFD. Okay, so about this is that CFD is, or computing in general, or coding and all that, is that some people, they can just nail it straight away. I was not one of those people, so and I realized that that's just life, and I just had to work on it all the time. Um, so it's just to let you guys know for students in this webinar that you really need to put the hard work in it, and then you'll get the results after that. So don't worry, you will get there as long as you continue. Okay, so next one is one of my favorites, which is the hands-on bits. So I like to tinker around with things. That's why I still have the car with me. And I realized that over the years, the toys that I've been playing with have just gotten bigger and bigger. Um, and it's all as a result from my experience in F1, which led me to these opportunities. So it started with this car over here. If you look closely, you can actually see the tether lines over there, so that the car keeps going in a straight line. And then this picture on the top right here was when had my placement with RTech in UiTM Shah Alam. You can see the chassis of the car behind there. Um, so they were still building it, didn't complete it yet at that time. And Dr. Ami in red in the middle there, so he guided me a bit on how to what to look for, so on. And then this was one of my projects in university where I moved on to building planes with a team, part of our projects. So the wingspan of this plane is about 1.8 meters. We used everything we had: FEA, CFD, electronics, um, electronic controls, using the ailerons, the flaps, servo motor. So it moved on from just building a physical car to something that we had to really control ourselves and code using Arduino and electronics. So if you can see my camera over here, I actually have the Arduino board. So if anyone is interested, it's an what you would say as a microcontroller, and there's a breadboard over there. So you connect wire, you connect this to your computer, you would put your code all in there, attach your sensors to all this, and then this is what goes in the plane in the picture there, and that's what controls the aeroplane. So we had GPS, accelerometer, gyroscope, all that. So this is the wing. You can see how there are 4 servo motors over there. And I had to design the structure of the wings, making sure that it can withstand the weight, the force, the gust winds, and all that. So it was really a good experience. And this is one of my teammates holding the plane, just to give some context on how big it is or small, depending how you look at it. Um, so the wingspan about 1.8 meters. I don't have the video to where it flew right now, or rather, it was just there were too many technical problems when I tried to play the video here. So yeah, I hope this is enough for now. And then after my second year, I did an internship at a aircraft maintenance company in Subang. So you can see how it's just getting bigger and bigger so far, from something that can fit in your hand. And then, yeah, sure, Artec was doing a car, and then I made a plane. And then now I was getting involved in how planes are maintained. So, fun fact, this is a piston engine, not a turbine engine for the aeroplane. Like, I didn't even know that the piston engines are still in use for aeroplanes, but apparently they are. Um, so yeah, because typically we just look at turbine engines on the big planes, right? Okay, so that was a good experience. And then this was me when I had the opportunity to visit the Rolls-Royce jet engine factory in Bristol in the UK. So the engine you see here me with is the one they fixed on the Eurofighter Typhoon, one of the fighter jets. And that was one of my favorite experiences. So again, it's just building up from F1. Like, if it wasn't for F1, I wouldn't have had the experience and ability to present and talk to get into my college. And then from there, I learned some more from college. And then I went to university, and I relate back to all the presentation tips that all the professors have given me before, how they do the engineering things, and I applied it there. And then from there, I got the opportunity to visit the factory also. So it all really just built up from F1. Back in 2013, I didn't know that I'll be visiting all this, but here I am now, So just trust that what you're doing is long-term investment. Long-term investment. Okay, so next. Oh yeah, and right now I'm interning at General Electric in their power division. So we work on providing the gas turbines for customers and so on. Um, so this is just an image I pulled out from them, and you can see how it just got bigger again. If it wasn't for the MCO, this is where I would be visiting also, looking at the power plant, maybe seeing how they carry out any maintenance, or how they install the gas turbines here and the steam turbines. So it's all, and all of it relates to each one of the pictures here has something in relation to each other where I've built on and learned from all the experience. So yeah, next one. Yep. So when it comes to hands-on bits, I just got to. I think it's best that everyone just keep looking for things to do, and don't keep your brain idle. So so you should just look for your own projects, make your own projects if you have free time, or get involved in something. Go volunteering. If you go volunteering, maybe you'll see what kind of problems they have, and then as an engineer, then you can see how you can solve that problem. Like one volunteering I did was this litter of lights. So we went to this kampung orang asli, and we set up solar lights actually using plastic bottles, just a light bulb and solar cell. So you use the bamboo stuck into the ground. You use some PVC pipes stuck onto the bamboo, and then use the solar panels and the light, so that at night it's not so dark in the jungle over there, where they stayed. It was deep in Pahang, in Cameron Highlands, around there. So that's what I mean by volunteering can help, or just look for things to do, and you'll get a lot of different kinds of ideas. Okay. Uh, so this is probably my favorite actually, which is the relationships I've built through all those experiences. So when I say the most rewarding is because these relationships last, especially if you make the right connections, or even if you haven't spoken to them in a while, suddenly you remember that, like you want to do something, but you don't know how to start. And then you remember that this person has done something like that before. So you can go back to that person and refer to him or her on how to do it. So that's what you call networking also. And I'll show you examples of what I did. So different kinds of people I meet. So back in 2013, this was during the nationals. Um, we made friends with this team called Corsa F1. Uh, So this is it. I actually made some friends over here. I still remember one of them is Arisa, another one Brian over there. Still follow each other on Instagram and all that, So we don't chat a lot, but it's good to know how they are doing and things. Um, so it's like um, it's a skill to be able to get to know people and build relationships, because they might you guys can help each other later on. So I learned how to mm, how do you say, interact with people more through F1 in schools, through presenting, And then I'm a school kid talking to professors in UiTM asking about how to do this and that. I mean, what kid is supposed to do that at that age? So yeah, I learned a lot just from this competition, and then I built on from there. After SPM, I went to this leadership camp called Program Kepimpinan Tun Razak. Just when I thought I met the brightest minds in F1, and then there was this camp. There were only about 71 of us, and this was from all over the country. We had a 2-week leadership camp, and they are all very, very brilliant people. They are scholars from Petronas, scholars from Bank Negara, straight A+ students, JPA top 50 students in Malaysia. So I was lucky that I got. And how did I get this camp? It was because of my experience in F1. When I had to go for the interview of this camp, I made sure to emphasize how I'm worth it in a way, just from my experience in F1, and they accepted me into the camp, and I built even more relationships. And these are the people some of the people I hold closest to, who I still talk to with until today. And then in university, I got involved in MSA, Malaysian Students Association, back in Southampton. So I was a president over there. Um, so over here, you can see that yeah, we were having fun over here, and we were mixing around with engineers and people taking psychology and actuarial science. So the point that I'm trying to show over here is that just because we're students are in engineering, I mean, it doesn't matter if you're a student or not. My opinion is that just because you're in engineering doesn't mean that you just be stuck in front of your computer or doing your maths or doing your physics or whatever. To me, that's not enough. It's not enough to just be smart at being book smart and being able to do the best design or something, you need to be able to communicate your ideas to the people. If not, because part of being part of the skills for being an engineer is you got to sell your product, right? So this is where you can build on your soft skills, on your how you talk to people, how you present to people, how do you sell your ideas. So that's why I went to all of this, just so that I learned how to talk more. And then there was Commonwealth Day in London. So this came out of the blue actually, because I was the president of MSA. Um, so out of all the different Malaysian societies in UK, one of these government officials basically approached UKC, the Malaysian umbrella body there for students over there. They asked, hey, do you have any students who would be interested, to join this Commonwealth Day, just represent Malaysia over there? So, it's just a one-day event. And I was like, okay, sign me up. Why not? So I didn't know that I could get it, but just take the chance because it's right there in front of your face. So all you need to do is just apply for it, because the worst answer that you can get is a no, which means there's no difference with your current state anyway. So why not just try? And I got it. And yeah, I mean, it was nice to interact with these people from other Commonwealth countries. We had someone from there's this lady from Canada, and then this guy from Pakistan, another one from Isle of Man, and then one of the other ladies came all the way straight from New Zealand. So this was at it was at Westminster Abbey, where Prince William and Kate got married over there actually. So I actually saw them in there, so it was pretty cool. And then I managed to meet with what's his name? Prince Prince Philip, is it? I forgot actually. Yeah, I can't find the picture unfortunately. But yeah, so all this so far because I managed to build on my talking skills and presenting skills and networking skills from F1, you know. And then this is probably one of the most significant events also which I've had, the Malaysian Students Technology Conference. So if you see the two front people in the middle there, that's me and my friend there, Zichao. So we were the deputy coordinators for this event back in 2018. So the point of this event was that, remember when I said you need to be able to communicate your ideas, your engineering ideas and so on. So that was the point of this conference we've had. So it's actually a conference by young Malaysian engineers, YME. So when they opened up, hey, does anyone interested to be the next coordinator for this event? Because we've had it since 2016, now it's 2018. Anyone else want to join? So I'm like, okay, why not? I'll try it. And then lo and behold, because I tried, I got it. It was a really rough ride. It was not easy at all, very time consuming. It did take a toll on my grades, I'll be honest with that. Uh, but it was worth it. Definitely worth it. I would do it again. Because if you see this picture, almost all of them are engineers, but we also have those who are doing law, those who are doing environmental science, and those who is actually doing medic. So all of us were able to communicate ideas with each other to carry out this event. Let me just show you this next picture over here. So because for this event, we also had to have sponsorships and so on, sponsorships all the way back from F1, and then we still have to do it, 5 years later, So we managed to get sponsorship from UiTM for the venue, and these were the kind of people who came in. And if I'm not sure if you can see clearly, but in the middle, in the grey dress, there was the former Minister of Science, Technology, Environment, Miss Yobi Yin. So we managed to get her as one of the speakers over here. So again, what I'm trying to say is that, oh yeah, the point of this event was that we had speakers from the different industries of engineering and technology, so that we can communicate those ideas to students who are interested, not necessarily just in engineering. Um, so that's why we have this kind of events also. That's why there's F1 in schools. So it really is really just the build up of everything. And then going through all of these events, there were so many different kinds of people with different ideas. Who knew a lawyer? no offense, but a lawyer could think like an engineer also. Like she gave my friend Ziling, she gave me a she was just so efficient at doing work. I didn't know like you could do that. So I learned a lot from the um, from her actually. So we learning from each one of us, from each other, staying up until 2 a.m., tidur sekejap, 4 a.m., wake up again. Oh, we got another idea. Let's do it. And then from all these events, I realized that talking is a skill. Back when I was in school, I guess I was quite an introvert. I think my friends and my teachers can confirm that. But now I'm quite outgoing, I would say. So talking is a skill for you students in this webinar. Build up on how you can speak. You don't have to talk all the time. There's a time for you to talk and time for you to stay quiet, time for you to listen. But when you need to present something, when you need to voice out something, it helps to know how to do it so that people listen to you. Um, and then meeting people leads to meeting other people, which gives potential for other bigger things. Okay, so this does not mean you'll get to meet your future girlfriend or boyfriend. Trust me, it doesn't work. uh, is it me and Johan? I don't know. Sorry, I was just looking at the chat in Google Meet. Anyway, so yeah, don't do it for the girlfriend boyfriend. I know you all are still young, whoever's listening here, but don't be tempted. Focus on the work first. That's me anyway. Um, so what I mean by meeting people leads to meeting other people is that if you go back to the MSTC event just now, I made a friend with this person named Shaukina, and I have another friend named Imran. So the two of them got close, and I got close with them, and Shaukina introduced us to other friends, and one of them happens to be a software engineer. So, and I got close to that guy, and that was only in the recent few months. So let me just share you what I've learned from that guy. I've learned about how you can do artificial intelligence or your home assistant without using Alexa or Google or Siri and all that. So it's just using a Raspberry Pi. So if you look at my camera, this is what a Raspberry Pi is. It's just a small computer, if anyone's interested. So you do some coding on it. You just put a micro SD card into it where you basically tell what it's going to learn. Um, and yeah, me from a mechanical engineer and then interested in aerospace, and now I'm getting interested in electronics and artificial intelligence and a home assistant. Just because I built on my relationships with people, because I got ideas from other people, they were willing to share experience also, and they were willing to teach. So it helps to make the right relationships also. And yeah, that's why you can see how much passion I have with relationship building, because this seems to be the longest that I'm talking of all the sections. Like CFD, what's the head, the hands-on, what's that, and then there's people, which I talk about most. So yeah, that concludes my presentation. I'll pass it back to Irina. If you have any questions, do ask away and enjoy the journey.
There you have it, a success story brought to you by an alumni, first-hand by an alumni of SMK Section 9. Now our Q&A slot will begin. Once again, para hadirin, you are most welcome to press the raised hand icon in the Google Meet. If you have a question to ask, you could also write your question in the Meet or Facebook comment section. It's so good to know how the knowledge that Mr. Azrai obtained when he was just in school helped him so far in his career and was so helpful and useful to him. So, is there any question from any of the participants today? Is there any questions for Mr. Azrai? Personally, I'm very interested in his journey so far. It's so cool to see how Mr. Azrai worked with just mini cars and now has ventured into playing around with planes and so many more bigger projects. Okay, we have a question from Mr. Azim Haris. He asked, how do you boost your confidence?
Uh,
So maybe we can get to know a little bit about how.
very good question. So when it came to conf, I was quite I still remember in school I was really quiet. So that's when boosting your confidence is even sometimes even now, despite doing all, I can still feel sometimes a bit scared or anxious when I want to present something. So how much you get used to it also in a way. So how do you build your confidence? To me, it was just practicing again and again, getting out of that comfort zone. That's one of the reasons why I got into F1 is that it gave me the chance to force me out of the comfort zone. So I had no choice but to present to people. I had no choice but to present to professors. Um, so in a way, it forced me again. It just the key word is zone. You need to get out of that comfort zone. So sometimes it doesn't work if you want to do it yourself. So it helps if you have friends to do it with. That's why I had a good team and we did it together. If you have someone to go through journey with together, that makes things a bit easier and at least you have someone to fall back on also. And then another way to boost your confidence is that make sure you know yourself. Do your research, and then that way you are confident in answering something. It's the same thing like doing an exam. If you're not going to study for the exam, then you do the exam. Of course, going to be confident, right? But if you keep doing your past papers, you keep repeating, you keep practicing, then you get more used to it, and you get more confident, and you get score higher. So it's basically the same thing, just that this is something that you don't teach all the time in school on speaking and talking and presenting and so on. So yeah, I hope it answers your question. Yeah.
I can definitely relate to that. I'm sure me and Kiss well know how we're very forced to present with everyone. But it's a skill and it's a very important skill to have. So we are so honored to be getting this chance and even presenting to you guys here today. Anyway, if there are no more questions, I think so we can move on. I'll
There is another question there
another
actually.
question. Okay, I'll read it out. Mr. Azrai, what would be the best way to secure a career path in the engineering department, specifically in aeronautics and mechanical? Thank you. Wow, that's a very good question. Mr. Azrai, go ahead.
Okay, so that's a very good question. But to be honest, I'm not sure if I'm the best person to answer that right now. Technically, I don't have a full-time job. I'm still doing my internship. It's just that I'll be pursuing further studies first. But anyway, what can I say? Best way to secure career path, engineering department. You got to be good at maths. There's no way around it. You need to practice your maths. And specifically in aeronautics and mechanical, or keep up to date with the technology that's going on. That has definitely helped me because when if you apply for something and you get interviews, you need to know what's going on in the current industry. So that's how I know about SpaceX. I know what's going on with NASA. I know about the astronauts who are currently in space. I know about in mechanical. I follow F1 still, so I keep up to date with the technology. So that's the as a student, that's what you can do right now. So don't worry about how much money you're going to make in your work, which job has the best money. Just do your job now and do it well as a student. There's nothing else to worry about. It's just study and do well. Do your research, gain your general knowledge. But in a way, to answer like how to have a career path in engineering department, I believe that question can be better answered by our next speaker actually, Encik Nasri, who literally has the experience in that department. So yeah, for now as a student, just do your job and do it well, and then the opportunities will come. It will come to those who have prepared. Simple as that. Yeah.
Um, and with that, I'll pass the baton to Christina to proceed with our event and introduce our next very special guest. Christina, take it away.
All right, thank you, Mr. Azrai. That was such an inspiring one, I guess.
So now for our last slot of the day, we have here together with us in our webinar series, a former well-known F1 Trackside Engineer for Petronas, specifically speaking, a Trackside Fluid Engineer for Petronas Lubricants. He is also experienced as a senior piping engineer with a demonstrated history of working in the oil and energy industry, skill in petroleum, gas, engineering, EPC and project engineering. He is a strong engineering professional with a Bachelor of Engineering BE, a double major in Mechanical and Aerospace Engineering from the University of Queensland. Kita agak mesti ramai-ramai tertanya, who is our final speaker of the day that has such an honorable background? So without further ado, I would like to pass the baton to Mr. Nasri Shafie, whom will share exclusively his first-hand experience as a former Formula One trackside engineer. You may take the lead, Prof. Sorry, Mr. Nasri.
Right. Right. Bismillahirrahmanirrahim. Assalamualaikum and good afternoon to Puan Roslina, Pengetua for SMK Section 9, Encik Gaus, YDP PIBG, Professor Dr. Nazid, the Deputy Vice Chancellor for Research and Innovation, UiTM, Keris Racing Team members and mentors, as well as distinguished speakers and guests, friends and colleagues. So a bit about myself. I was my hometown is in Penang. I spent my whole schooling years in Penang, and then I got the opportunity to further my studies in the University of Queensland, Australia. But before I went to further my studies, I was actually I did my foundation in Intech Section 17. Previously was with UiTM. Now I'm not really sure. So excuse me for my ignorance. So spent 4 years in University of Queensland, Brisbane, and started working in Petronas in 2010 in mechanical engineering. And then in 2018, before that, I was assigned to a few projects. Basically, I did a few offshore projects and I did one big onshore project, which is the Terengganu Gas Terminal as a piping engineer. And then I got the assignment to represent Petronas as a trackside engineer for Petronas from 2018. And luckily enough, my stint only lasts 2 years. So 2020, I was assigned now at my current assignment, which is in Petronas Research. So, I mean, I think it's also a blessing because when 2020 was a very unprecedented year, basically COVID happened, and if I was actually traveling, I don't know, it would be a different scenario altogether. So, moving on to my presentation. So this is the outline of my presentation. Okay, so Petronas, basically, we power Mercedes AMG. Basically, fuel, lubricants and functional fluids are developed and supplied by Petronas. Petronas considers Formula One as the best test bench to test our fluids. It's a testing ground to make sure that what we develop is high performance and then eventually can be translated to the road. So I will switch this presentation to a brief overview of what we do basically.
The new power is here. The Over 30 years of motorsports experience and 7 Formula One World Constructors Championships. Our best fuel for unbeatable performance is now yours. The all-new Petronas Premax 97 with ProRace. Engineered with the world's first advanced dual friction modifier. Power to move beyond. Power, responsive, efficient. The all-new Petronas Premax 97 with ProRace.
Okay, back to my presentation. But just checking out, Arena, can you hear the sound?
Yes,
now?
the sound was perfect. Are you presenting right now?
Yes, I'm back to my presentation.
All right. Proceed.
Oh, sorry. Okay. All right. So, what did I do before during my what you call stint as a trackside engineer for Petronas? Well, basically, we are representing Petronas. I mean, in front of the media worldwide, and making sure that Petronas basically delivers its products. So we look after the products that Petronas supplies to Mercedes and the customer teams, which are the Mercedes customer teams. This includes the fuel, Petronas Premax, the Synthium lubricant, and Petronas Tutela functional fluids. So previously you saw an advertisement basically for the new Petronas Premax Pro Race. I mean, try it. I've tried it before. It's good. You can feel the difference. So that is basically what Petronas is aiming for, to translate from what we learn at track to the road. So, and then we bring it to the masses to make sure that everyone can feel it as well. So, moving on to what I do at track, we will analyze the fuel using the gas chromatograph, which is this equipment here on the bottom left, to make sure that the fuel is consistent and it meets the regulation, so that we look for contaminants that could affect the performance, or maybe some contaminants that could actually cause disqualification by the FIA. For those that are not used to F1, the FIA is actually the regulatory body. It's like the policeman that we have, what you call, for the general public. Okay. The next thing that we do is we also analyze the engine and gear oils with a spectrometer, which is this on the bottom right, to determine the amount of wear metals in the samples after each session. So basically, after the engine has run, so it's like this. When the car is run, or when the engine or the gearbox has run, basically there is going to be friction between the moving components inside the moving parts. So the engine is moving, and there's friction between the metallic parts. So you will get some small amount of debris coming out from the friction. And then what we do is basically to see whether the debris that we get, is it excessive or less excessive. So if it's excessive, then we can tell the power unit engineer that there is a problem, actually, that we see a problem here with the metallic wear of the engine or the gearbox. And then eventually the engineers can then decide whether do we continue on to use the particular power unit, or do we need to switch to a different one. So it's better, actually, in F1, if you take a switch, if you switch the power unit or you switch the gearbox that has exceeded the allocated amount of components that can be used in a season, you get a penalty. But it's better sometimes to take a penalty rather than to not finish the race. So what you call, to win the world championship, you have to finish the race first. Then you can, what you call, get the points. If not, then there's no use. So some analogies that I can give to the two equipment, the gas chromatograph in the bottom left is like it's like this anti-doping agency. If you have like high performance athletes, they have to, even e-sport players now. So even e-sports players, they have to be what you call to be drug tested. So you have to give your urine to the anti-doping agency, and then to see whether you are taking any high performance drugs or something like that. So this ensures actually this gas chromatograph, or GC we call it, is even used for that purpose as well. So you can see whether there are any what you call making, the FIA wants to make sure that we're not doping the fuel to go faster than the what you call, than the competition. And the second one, the spectrometer, how we go about and analyze the engine oil. So it's similar to how we take a blood sample from our body. So for example, I may have a lot of what you call blood sugar or cholesterol in my body. So I take a blood sample and I can check whether it is excessive or not. So this analysis of the wear metals using this spectrometer is also functions the same way. So I mean, it's better if someone shows you how it's done. So I am going to show you how it's done, but I'm going to get a help from some few of my what you call some famous people.
Hi everyone, so we're here at the Trackside Lab. In this room, through the race weekend, this is where the engineers sit here and analyze all the lubricants that we have within the car, so naturally the fuel and the oils. So I'm going to take you through a bit of the sequence as I've watched it over the past 6 years, what's been going on. Hopefully I know what I'm doing, but I'm going to do a fuel test. So basically it's just to match what beginning of the weekend they give a fuel sample to the FIA, and throughout the weekend they have to keep making sure, particularly when they open up new barrels, that fuel sample matches the DNA of that fuel sample they've given to the FIA. So I'm going to take you through that sequence of how they get through that. So just put it into here. Doctor's gloves. See how clean that is? So the Petronas works so hard to make sure that this is the most efficient, clean fuel, give us the most power. And then they go to the laptop over here. They have this machine that scans the fuel, and I'm going to just run a sequence now. If you watch. So obviously I can't show you the results that we get from this test, as it's top secret, and we don't want the other teams to know exactly what's happening. But on the computer we'll have a sequence of information that the guys were analyzing all this data throughout the weekend. So efficiency is key, consistency is key, and these guys work so hard and this is why we have this lab, so we can be as efficient as possible. And as you know, like for us, we only have 3 engines. Limited on our gearboxes, so it's very, very key that these guys are doing their job to the utmost. So yeah, it just shows how hard, even to the tiniest detail of something as small as a tiny fuel sample, you can really make a difference to whether or not we win or lose on the race weekend.
Hey guys, I'm here at the Petronas Trackside Lab, and I'm going to be showing how to do an oil analysis. In a race weekend per car, we're doing between 16 and 20 oil samples, and that is just for the reliability. We are making sure that there's not too much metal in the oil, and that way we know that everything is working as planned, basically. So I'll show you how it's done. So we take the dirty oil, why it's this color instead of the one before is the job of the oil is also kind of to clean the engine. So there's all kind of dirt and metal particles here, and we need to check that there's not too many. It's actually only about 2 mils that goes into the test. So we start the machine. Normally it takes about 20 seconds. And what's actually happening there, the oil is kind of burning, and then the machine can detect the amount of metal inside the oil sample. If it's within the normal range, then that's all good. We're all happy. So now it's finished. Have the results. I'm not going to show to you, but looking good, and we're happy to run the engine flat out again.
Okay. So basically, I mean, to those of you are not familiar with Formula One, both of them are the current drivers for the Mercedes AMG Petronas Formula One team. And unfortunately, they don't do our samples every single day. I mean, we have to do the samples, so it's basically 20 samples per team times about 3 teams, so 60, so a few hundred samples per week. But they do drive well, and they get the championship. Right? Okay. So what do I do in a normal working week? So like the world champion has mentioned before, we take the fuel sample from the fuel drums, and then we make sure that the fuel is consistent in the drum, and we also take the sample of the lubricant from the lubricant lubricant can, as well as we take, this is actually in the bottom left, is actually the fuel rig, or we can also call it a fuel pump. So basically we take the fuel from the fuel drum in the top left into the fuel rig, and then it will go into the car, and we also take the sample from the car. And this is what we're doing here is we are taking an engine oil sample from the car. Okay. Next one. So a bit on what do I think about STEM? Why STEM? Why science, technology, engineering, and mathematics? So it's basically gives you an interesting experience. Not just interesting. It's what you call it's there is infinite possibilities in learning STEM. So here is a picture of me together with my group of mechanical engineers. We build up good networks. We help each other through and through. I mean, if we have a problem, when we meet, there are a lot of good people here, so we can ask for help. They will assist. We assist each other, share our experiences, how to attend to problems. Basically, what we do is when we come up with a solution, is the solution that is for the good of the company and the people working within our facilities. So here is some of my colleagues that I met during my assignment with for the T-Gas project. So for the T-Gas project, our main contractor is Samsung Engineering. And here are, yes, there are in fact the four beside me are South Koreans. So we work with them to deliver the project, which is the Terengganu Gas Terminal, as well as not forgetting the other experience that I got was working with the best the best Formula One team in the world. So you can see that they value what you call teamwork. They expect you to be responsible, to be good in what you are doing, to be fast in what you are doing, and then basically the main culture that they have is there is no blame. You do your best. If you what you call, if you say you mess up, you admit I mess up here. So you tell them that, and they will say, okay, but I mean it's a lesson to be learned. So if you are what you call, if you make a mistake, you admit to it and you move on, because that is and then no one blames you for it as long as you improve and you what you call, the most important part is that you improve and you deliver the next time. And then here they are doing a pit stop. It only takes less than 2 seconds to do pit stop. You can see the what you call the synchronization, the harmony of each particular person doing the pit stop. So everyone has a function there. So at the top in the front wing of the car, someone can actually adjust the setting of the what you call of the wing, depending on what you call what tires they are using. At the side of the tires, someone will hold the tire, someone will push in the tires, and someone will take the old tire out. And then at the back, someone will jack up the car for the what you call for the pit stop to be done. Next one, it is rewarding. So here is a picture of me and my friends during my studies in the University of Queensland. So, but we were not in Queensland. If for Queensland, I should have shown you the picture of Gold Coast. So this is in New Zealand. So we were hiking up Fran Josef Glacier. So these are good people, and all of them are STEM graduates. So two of them are working in Petronas. One of them is with one of I mean the other one is in Singapore, and then we have another one doing his postgraduate in the University of Tasmania. So and also it also brings you places. I mean here is myself in South Korea. This is in fact when we got the chance to visit another project that's also happening in South Korea. I think you've heard about it. It is the PFLNG 2. Sorry, PFLNG 1. The first floating liquefied natural gas plant that, I mean, it's basically a gas plant that is floating in the middle of the sea. It's the first in the world, and Petronas is proud to be what you call the one that is bringing it to what you call to be the one that is developing, that has developed it and delivered it. And here for football fans, I got the chance to visit this particular stadium. More than a club. So this is FC Barcelona, Camp Nou. And I think the most important bit of STEM is actually the spirit of giving back. Like what Mr. Ramlan and people who has what you call brought you up there, or you give more to the people that to the nation and the people. So this is the spirit what you call we should have in our life. We give back to the nation, to the people, to the community. So here is the picture of me in front of the completed Terengganu Gas Terminal. So it's what you call this is a news clipping of the Terengganu Gas Terminal when it's launched. And here is us telling the Petronas story. I mean, for us to do this, for Petronas to do this is basically to generate what you call revenue, and this revenue is basically to be given back to the people of Malaysia. And this is one of the highlights of Petronas contribution during the COVID-19 crisis. And STEM is important also that all the frontliners out there, the doctors, the nurses, they are STEM people. So we cannot we cannot be emphasized enough that STEM is very important for for the nation and the people. So a bit more, if you are interested in F1, so obviously you need STEM. And then F1 hires the best talent worldwide. It's both hard work and teamwork. You need to have a good team. You need to be a network, like what Mr. Azrai has mentioned. You need to be in a good team. You need to be a network. You need to get along with people. So that is the soft skill, part there. It is challenging because you have to travel the world. With COVID, it's even worse because every single day when they go, they can't even go back to their to their families. In fact, they're afraid to to infect others with COVID if they got one. But it is rewarding. So in closing, I hope to use the lessons that I've learned to develop myself and contribute to Petronas and the nation. And I am happy to share with my experiences with anybody that wants to ask. As long as you ask, I mean, as long as you are proactive to ask, I mean, you can get everywhere. This is the picture with the team. And before that, I'll just end with a video. Is it okay, Arina?
Of course, no worries. We'd love to see it.
It's race week in Abu Dhabi, the final race of the season, and we're here with Nasri, one of Petronas' trackside fluid engineers, to meet with four of Petronas' competing teams in this year's F1 in Schools World Championship. Nasri, are you excited to meet the students?
Absolutely.
Right, let's go inside and meet them.
So, to have good teamwork within your team, study well, look at all the angles, and never give up. That's the most important thing. And always have this can-do attitude. Formula One is always about can-do.
Nasri, what do you make of the quality of the work you've seen today?
Yeah, it's impressive actually. I mean, I'm impressed when they mentioned that you have like a CNC machining at school or 3D printer at school. I mean, shows how far from when I was in school and how far it has become now.
You've all worked so hard that it would be quite fun to see what real life racing's like. Who's up for a bit of racing this afternoon?
We're here now to surprise the kids F1 in schools. Super excited to see them and support me.
I think we should champion Lewis Hamilton.
This is where I started. You got to start in the right place.
Oh, how cool is Nasri, thanks so much. Lewis Hamilton, thank you so much. Let's go and have some fun on the track.
Brake, buddy. Brake. Oh. You guys on Instagram? Yeah! I'm gonna be on my Instagram. I'm gonna come up there, okay? Good job.
Wow, what
what an interesting video. It's so sad that our team cannot experience anything like that this year due to COVID-19, but we are looking forward to some sort of activities for our World Finals. Betapa hebat ya menjadi trackside engineer ni. I wonder how many people here today would like to have a job like Mr. Nasri or work in this field.
That's it. I was wondering the same thing. So, and if there weren't many people before this, I'm sure pretty sure like lepas kita dengar talk Mr. Nasri ni, everyone was like kind of inspired. So again, I repeat for those yang nak tanya soalan, anything to our Encik Nasri here, if you're more than welcome to take this chance and raise your hand in the Google Meet. If you have a question to ask, you could also write your questions in the Meet chat or Facebook live comment section.
As Chris said, our Q&A slot is open, so do feel free to ask your questions now.
I can see a hand raised by Puan Rostina, I think.
No, I just would like to ask, say a few words before you end the session, actually. But it's great to know you have met Lewis Hamilton as well, Ahmad Nasri.
He always passes by us every single time. So he takes care of the team, the team. He makes sure that he greets everyone because he knows that without teamwork, I mean, every single part of a car, every single nut is important. So, I mean, that's how important each and every one of the team is.
Such a great experience, Ahmad Nasri. Excellent. You meet all the great people.
That's a beautiful way to say that. So we have a question from Facebook. It's what are the requirements to be an F1 engineer? Asked by Mr. Khairul Ikwan. Mr. Nasri, maybe you could answer.
Requirements to be an F1 engineer. I think I have to somehow echo what Mr. Azrai mentioned. You have to be good in maths because you need to be in engineering student first. But at the same time, you have to be good in working with teams. So yeah, you are able to communicate your ideas well, and then I mean, you believe that you can do it. Basically, you just have to work hard, find the opportunities whenever it presents itself. So raise your hand up, like what Mr. Azrai has done. Raise your hand up and then say that yes, I want to do this and I want to pursue it. Because I've met a lot of people. I mean, there are a lot of nationalities working in F1. So Japanese, Americans, a lot of people. So and those are not the typical F1 countries. So it's interesting to see that actually.
All right. I also would like to personally ask a question. I saw in the videos that you presented, you've worked with so many amazing people. I would want to know, in your career as a former F1 trackside engineer, what is the highlight of your career and what is the moment that you would want to relive?
Moment I would like to relive. Yeah, it's quite a difficult question there. I think it's basically the spirit of teamwork in the team. The team is basically what you call part and parcel. You come around to the track, you meet the team members. I mean, initially when I came in, I don't know anyone inside except for my colleague, and even then, he was new to me. So you start to build the relationship building. You get to know the person as a person. That's the most important part. And you work with them. You build the cohesive relationship because, and what you call, you help when it's needed. And so they will respect you as a person, and basically you will deliver the results eventually.
Thank you so much for answering my question. Once again, was last call. Anyone else would like to ask a question for Mr. Nasri? Do raise your hand, or you can comment in our Facebook Live or in the comment section of our Google Meet. All right, no, if there is no more questions to be asked, I think so we should proceed with the event. What a great selection of questions that were asked. I'm sure Mr. Nasri would love to answer more questions, but I'm afraid we're running out of time. It was such a pleasure to sit down and talk with all our prominent speakers. Before we move on and start wrapping up before we move on, we would like to actually present once again our video presentation at the end of this webinar. But do not go yet, because after this, we will be presenting the QR code and the link to get your promised e-certificate. All right.
We have a team that is representing SMPS Section 9. Now this team is actually called Keris Racing. Keris Racing.
Hi, my name is Irina, and this is, and we're from
Keris. I said my phone. Keris Racing.
While you and me repeat, this bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire. Yeah. My bones crave your skin, temptation within, mistakes ignite the silence. Nightmares creep while you and me repeat this bittersweet heat. It's suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Alright, so with this, I wish we could chat a little more, but I'm afraid our webinar is coming to an end. So before we could wrap up this episode, I would like to say thank you to those who made it with us to this end. But don't go yet. We've posted registration, I mean your attendance. And also kepada para guru, tidak kira dari sekolah mana atas jemputan JPN, kami akan tangkan QR code untuk di-scan yang akan didirectkan ke link kehadiran bagi mendapatkan materi SPL KPM anda.
Yes, for the rest that stuck with us the end to the end, do click the link in the chat or our Facebook Live. That will lead you to a Google form. Fill it in and you should receive e-certificate emailed directly from Team Keris Racing. Do take note, the e-certificate will be considered peringkat negeri, ya, and it will be valid to give you extra co-curricular marks. Thank you so much for joining us.
Can I say a few words, please?
Yes, of course.
Okay, before we end, I would just would like to thank all the prominent speakers. Thank you, Encik Ramlan, our senior lecturer, for sharing the dynamics and the physics of inner car motion, all right, and F1 cars. It really refreshed back my memory on physics. I'm a physics major, by the way, so I really enjoy your presentation. It's very, very good. I hope the students really, help them understand the physics of car in motion and what is needed to build an F1 cars. And to Encik Azrai, our ex-Niners, yeah, thank you for sharing a great experience into becoming who you are today. Excellent experience in F1 in schools and led you to become a great, I hope you're going to become a great engineer. Definitely, I'm sure of that. The way, you get involved yourself in so many activities that develop your soft skills as well, right? To Encik Ahmad Nasri, again, engineer for Petronas F1 was such a great experience. Definitely what you shared really inspired me as well, for you to meet all the great people, great sharing of your experience in the lab, analyzing the engine oil and whatnot, making it better for the public. And a lot, yeah. Thank you so much for sharing that experience. And of course, I think for all the three speakers, meeting the great people in whatever you are doing, that is the most, I think, what they call it, something that you can always treasure it in your heart, especially. I think that is a great thing. Thank you to all the participants. Thank you to Keris Racing. You have done a great job. I hope you get whatever you wish for. Definitely, I'm rooting for you. I'm hoping that we're going to be the champion in the world finals, inshallah. Okay, on that note, thank you again. Back to you, Christina and Irina.
Thank you so much, Roslina, for the kind words. Thank you so much, Roslina, for the kind words. I just wanted to inform everyone that the link for the e-certificate will be open for everyone, for all our participants of the day. If it's just exclusively the markup curriculum lah will go to the students, and the QR code is specifically for cikgu-cikgu untuk menerima mata SPL KPM. Alright, I hope everyone is informed. Kiss back at you. Sorry.
Berakhirlah sudah webinar series Inside the Minds with Keris Racing first episode. We would like to say thank you. Terima kasih kepada semua kami ucapkan. Semoga berjumpa lagi pada episod akan datang. Thank you.
Thank you everyone for joining. Thank you for making it at the end of the program. Assalamualaikum warahmatullahi wabarakatuh.
Bye.
Thank you. Bye. Waalaikumsalam.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam.
Thank you so much for joining us. It was a very interactive day and very amazing one too.
I'm completely rooted to my seat throughout the seminar. I only go to the kitchen just to get some coffee and that's it. I've been rooted to the chair throughout
That's
the
good
seminar.
to know. That's good to know. It was a very intriguing talk and they shared a lot of intriguing topics. Thank you
Yeah,
so
all
much.
great speakers, definitely. Alright, terima kasih Ahmad Nasri, terima kasih Cik Ramlan, terima kasih Azrai.
And terima kasih to you, Puan Roslina.
Yes.
Thank you so much for joining. Bye.
Terima kasih Puan.
Everyone.
Thank you.
Thank you, everyone. Okay, who else do you have?
Thank you, Encik Nasri. Thank you, Mr. Azrai. And also
Thank you. Thank you for helping making this a reality.
No worries, no worries.
It was
Pleasure.
just an idea last week, but then we made it happen in 1 week, and it's an amazing event. I think so. It's something that other
Erina,
schools can. Yes,
Erina,
Tina.
mohon speakers tunggu sekejap kita ambil gambar.
Boleh, tak ada masalah.
Semua
Anyway, thank
dengan
you so
mentor
much for
sekali,
making this a
mentor
reality.
sekali ya. Mentor sekali.
Really interesting sharing your thoughts. Thank you so much for all the kind words. Thank you. I think that this was an idea and now it's a contoh for other schools to
Just to mention Azrai, why don't you visit the school one day?
I wanted to, and then COVID happened.
You should come and visit.
Yeah, I usually visit every year when I come back. Betul tak, Cikgu Kash? I come, right?
Yes, betul.
Yeah,
Banyak kali juga Puan Azrai datang. Okey, mohon semua.
Azrai tak silap ada cousin kan dekat sekolah? Bukan?
Cousin? Danish.
Adik lah.
Oh, adik ke?
I got adik ada, cousin pun ada. So
Form 5 dia sekarang kelas.
yeah, Danish is form 5, but my younger is form 2. Right.
Oh, so that's your little brother. He's in form 2. Selalu datang tegur-tegur kita orang.
Yeah, he's a completely different personality than who I was in school
He's
lah.
very, very outgoing. Very outgoing.
Happy go lucky
Erina,
lah. Yeah.
Erina mungkin kenal Syarif.
Sorry,
Pengawas.
yang mana tu?
2018 students.
Nina tak berapa kenal ramai.
Straight A student, you know. Straight A student.
Straight A.
Pengawas.
Siapa tu cikgu?
Adik Azrai.
Oh.
Okay. Actually.
I don't think I was actually in school when I was in 2018. Ina rasa Ina tak masuk lagi tingkatan.
Oh, tak masuk lagi ya?
Ina kan baru form 4.
Oh, iyalah baru.
You're form 4 this year.
Yes, I'm the youngest